Hi, good evening, everybody. Tom, K3YH. It's session number 2 of the extra licensing class. I'll hand it straight over to Roll. Go ahead.
Hi, guys. Welcome,
And ladies,
and ladies and gentlemen, and
folks.
children of all ages, as they like to say. Um, we're now on chapter 3. This is our second session. Remember, chapter 1 was kind of an introduction to amateur radio licensing. Excuse me. One second. So, um, we're on to and then chapter 2 was our first actual session of information that was on the test. We're now to chapter 3, which is primarily rules. And at the very end of the evening, I will begin an introduction to the math that we will need for the following section. We'll talk more about the math when I get there, but I don't want you to be put off by the math um, because we're going to, for those of you who have some familiarity with math, uh, this will be a reminder. For some of you who don't, this may be more than you can pick up in just one session of instruction. But don't worry about that because there's several things. We're going to teach you how to find the right answer without using a whole lot of math. And we're going to have a special math training session sometime in the next 3 or 4 weeks that will give you all a special who needed a special evening just devoted to the math on a different night, probably a Tuesday night. And we'll record that session for those of you who can't make it.
Don't
So
quit, don't quit because of the math.
please don't. First of all, there's not that many math questions on the test.
You can get all the math questions wrong and still pass.
So I
But,
don't want you to do that, and you won't do that.
but it'll be close.
So, but there are ways to figure out the answers if you understand what the question's about, and you can pick out the right answer. And I think that's great. I think understanding the right answer is better than using a bunch of formulas that you have no idea what they even mean, and get the right answer. So this is a good way to learn and a fair way to learn, in my opinion. Okay, so let me share my screen here. Um, okay, so we should.
Are you drawing tonight? Yep, I see your tablet.
Okay. So,
Try to write neatly.
yeah. So I found out that somebody said, "What was that strange font on your PowerPoints?" Well, that wasn't strange font on my PowerPoints. That was me writing on this blackboard, and I, I've realized that maybe there are some people out there that do not read cursive. I mean, my kids can't read. My grandkids can't read cursive. They don't get taught it anymore in all schools. Some schools still do, some don't. So I tend to lapse into it. I'll try not to do anything too cursive-y. Uh, and if somebody's having trouble, just send a chat to Tom, and he'll remind me that people can't read what I'm writing here. But I'll try to be as neat as I can. We're going to talk about 3.1, which is going to be operating. I hope you can read this kind of font. Operating standards is what it's called. It's a meaningless title, really. I'm not sure. They just needed a title for the section, and they needed to break it up. And the first thing we're going to be talking about is frequency. So, we have ham band frequencies, and we have to stay within those bands. And the first questions are primarily about rules about staying within the band. And you know that you are not permitted to have any signals outside the band. So let me remind you of how modulation works here, just briefly. So if this is frequency here, and if we talk about amplitude modulated signals, an amplitude modulated signal without any modulation on it, without any information, is just a single frequency that's transmitted. This is AM of the type that's found in what's called the AM broadcast band down there, 55 to 1600 or whatever it is down there at the low end of the spectrum. And it's amplitude modulation. What does that mean? Well, in time, this is frequency. So these are frequencies. This is not plus and minus. This is, maybe this is like 14.000 and this is 14,350. If that's the case, this would be the 20 meter band here. And if we're talking about frequency, this would be the display of a single frequency being transmitted. It would look in time like this. So it would be time going this way. And it would be a signal of constant amplitude. I'll stretch it out, but it's supposed to be symmetrical. So it's a sine wave. It's constant amplitude. Of course, the frequency is very, very high. It's 14 million cycles per second. When we modulate that signal, we modulate the amplitude to contain information. So a modulated signal with, say, a single tone on it in time would look something like this. So I'm drawing this hashed in here because this frequency is really, really high compared with the audio tone. Let's say this is a 1 kilohertz modulation, and this is a 14 megahertz signal here. So there's what's called the envelope of this signal is right here. You can see that the amplitude of this radio frequency signal is varying at a 1 kilohertz rate. In other words, this is a 1 kilohertz sine wave. There's no real sine wave here like this. It's just connecting the dots of the peak signal here to make this blue line. That represents the envelope, as it's called, of the modulated signal, the envelope. So if we modulate this AM signal, this is called the carrier. This thing up here is called the carrier because it carries the message, but there's no message being sent. Now when I modulate with 1 kilohertz tone, I get two signals in addition to the carrier. One on this side, one on this side. They should be the same amplitude. They are 1 kilohertz away from the carrier. And there's two of them, one on either side. If we modulate with a whole band of frequencies, like your voice or music or something like that, then there's a whole band of frequencies on each side of the carrier. They're symmetrical. They're supposed to be the same, except the low frequencies are all down here, and the high frequencies are all up here. And they look the same. I don't go down to zero here because there's no zero frequency. Below 100 hertz or so, there's no signals being sent. So this represents the bandwidth of the signal that's being sent with two symmetrical bands, one on each side. This one's on the upper side, so it has the fancy, unexpected name of upper sideband, the USB. And this is the lower sideband because it's in lower frequency. Now notice that on the lower sideband, on the upper sideband, the lower frequencies are at the low end and the high frequencies are at the high end. But on the lower sideband, it's exactly the reverse. The lower frequencies are on the high frequency side, further away from 14.000, whereas the lower frequencies are lower in frequency. By the way, on this scale, 14 megahertz is way out here someplace, because this bandwidth here is typically only a few kilohertz, 2 kilohertz or so, 2.5 kilohertz, something like 2.8 kilohertz bandwidth for our voice signals that we transmit. This is double sideband AM. This is AM double sideband because both sidebands and the carrier are being sent. And you know that single sideband, the idea behind single sideband was, why waste this power sending the carrier? The only thing the carrier does is tell you what the frequency is exactly, not the relative frequency, but the exact frequency of these low tones and high tones on either side by their distance from the carrier. We can always put the carrier in later. We'll have to guess at where it ought to go, but we can tell from the sound whether we put it roughly at the right place. We don't have to transmit it. We can stick it in our receiver. By the way, we don't need both of these sidebands. They both have exactly the same information on it. So let's just send a single sideband. And what is really single sideband? Suppressed carrier. And the carrier is very suppressed. It should be, you should not even be able to hear it. Single sideband, suppressed carrier. So, if the frequency that we read, the frequency we read on our radios is this frequency. Oops, I'm writing cursive again. Frequency that we read on the radio is the carrier frequency. Interestingly, that carrier frequency is not even transmitted, but it indicates where we are inserting the carrier to receive the signal. It's where if we do it right, it will be where the carrier would have been had it been transmitted. But that means that in the case of single sideband, upper sideband, all of the frequencies being transmitted are higher than the frequency that we're reading on our dial or reading on our display. And on lower sideband, they're all lower. And that's the gist of these questions. It's just knowing that you can't put your radio right at the edge of the band without running the risk of going outside the band. And it's important to know whether you're on upper sideband or lower sideband and which end of the band you're in. At the upper edge of the band or the upper edge of your frequency allocation, you can't use upper sideband with the carrier set right at the edge of the band because the entire single sideband will be outside the band. However, it's perfectly okay to use lower sideband with the setting at the very high end of the band. And the same thing, of course, occurs if you're running lower sideband. You can't go to the low edge of your allocation all the way down to the low edge with your carrier frequency because the entire lower sideband will be out of band. Well, on 40 meters, that's lower sideband. Lower sideband on 40 and 80 and 160, we do lower sideband. All the other bands, we do upper sideband. So on 40, 80, and 160, we have to be careful about staying away at least 3 kilohertz away from the low edge of the band. And on the rest of the bands, we have to be 3 kilohertz away from the top. So that our sidebands aren't out of the band. So what are the questions? When operating single sideband with the transceiver displaying carrier frequency, and by the way, some radios allow you not to do that. You probably have to go out of your way to not do it. Definitely don't do it. Everybody talks about the carrier frequency, the carrier that's not their frequency. When they ask, and they say what frequency they're on. The only people who talk about any other frequency are the people who allocated 60 meters to us, and they call the band in the government, they call it by the center of the band, not by the not by the carrier frequency, which is really weird. But anyway, we've learned to deal with that by translating that to our carrier frequency so we can set our radios properly. Okay, when operating single sideband, what is the lowest displayed frequency at which a lower sideband emission is totally within the band? 3 kilohertz above the lower band edge. Question E1A02. Then there's some specific examples on page, I think it's 3-4. It says if you have a signal that has 3 kilohertz bandwidth on upper sideband, and you are transmitting on a carrier frequency of 14.348, that would be illegal because the upper band edge is 350, and it would be outside the band. May an extra answer a CQ of a station on 3.601 lower sideband phone? Now this is because the lower edge of the phone band for extra on 80 meters is 3.6. So if you were transmitting on 3.601, that would be lower sideband, and obviously you would be out of the band. So the answer is no. And this question is assuming that, as is the case almost all the time, you're transmitting on the same frequency that the person is transmitting on. What's the maximum legal carrier frequency for a 20-meter signal upper sideband data? That is a data signal that's being transmitted in an upper sideband with 2.8 kilohertz bandwidth. Well, if it's upper sideband on 20 meters, the maximum legal frequency would be, it's limited to 14,150 minus 2.8 kilohertz. That's 2.8 kilohertz. And so this comes out to be 14.1472. So because you can't go above 14,150 with digital signals, and because the bandwidth, as the question says, is 2.8 kilohertz wide, then you can't go any higher than 14,147.2. Parenthetically, there is no regular digital operation that close to the band, and especially with 2.8 kilohertz bandwidth. This does require that you know how to go from megahertz to kilohertz, that you know that 2.8 kilohertz is 0.0028 megahertz. So this is megahertz, 14.15, and this is kilohertz. This is still megahertz here, 0.0028 megahertz. Or if you did it in kilohertz, it would be 14,150 kilohertz and 2.8. So you'd have to subtract 2.8 from 14,150, and you would get 14,147.2. Any questions about that? All right.
Two questions.
Yeah.
One is why do we use 3 kilohertz for the bandwidth for the single sideband questions?
Had to use something, and the actual bandwidth for some people do have bandwidths as high as 3 kilohertz on single sideband. Most people set it lower. On 60 meters, you're going to find out in the next section, it's limited to 2.8 by regulation. Many people have it set less than that to narrow the bandwidth a little bit. So there's no one given number for it, but 3 kilohertz does represent a possible, pretty much upper limit for the bandwidth of a single sideband signal.
So, and the point is, if you know your signal bandwidth is more than 3 kilohertz, then move up or down accordingly. Somebody asked me this question by email and said, well, if I'm, if my signal is occupying double sideband, in this case 10 megahertz, where do I need to be? And so half of that is 5, and you have to be at least 5 kilohertz away. So,
yeah.
So
the same principle.
Kind of like by design in typical amateur practice, a single sideband signal is around 3 kilohertz, but depending on the actual bandwidth of your whatever modulation you're using, you may need to, well, not you may, you must consider that.
But I would never go closer than 3.
Absolutely.
It's just you're right playing it.
Yeah, I'm just saying that you might have to go more.
Yeah. Yeah, it might have to go more if but if you know your bandwidth is
You know
greater.
your bandwidth is more. Like, for example, if you're using FM.
Yes, FM would be a lot wider bandwidth.
So
Okay.
the other question, I don't know how much you want to talk about this, is why do we use LSB and for lower frequencies and USB for higher frequencies?
Well, without going into a long story about it,
Exactly.
back in the
How about
40s,
because we do?
because we do, yeah. Back in the 40s, way they generated upper and lower sideband, it turned out that it came out that way. And ever since then, we've stayed with it. That, in a nutshell, is it. Another way of putting it, it's totally arbitrary, but that's what we do.
And by the way, it's not a rule. You can flip it around if you want.
Yeah, but good luck with that.
Yeah, you won't talk to many people, but you're welcome to try it.
Nobody will be able to understand you because upper sidebands on lower sideband sounds totally incomprehensible. You can tell it's a voice, but you can't understand it because all the high frequencies are low frequencies and all the low frequencies are high frequencies, and so the result is mishmash. And if you're active at all, you've heard the wrong sideband probably sometime. Although almost all radios, when you buy them, are set to go on lower sideband when you go to 40 meters and 80 and 160, and they're all designed to go on upper sideband everywhere else. They're not designed; they're set to do that. But you can change it,
You can
and it's
change if you. Okay, that's it.
so now we want to have some. There's some questions about 60-meter rules. Remember, 60 meters is this band that came along relatively recently. It's not the most recent one. The most recent band, I think, so for the real long wave ones at 2,200 meters and so forth. But this band came along when the government decided to share their frequencies with us and split it into 5 channels. This is very unique in that this is an HF band that we have 5 channels. And as I said, the original rules specified the center frequency of these channels, but we don't read the center frequency of a channel. We read the lower edge of the channel. And the channels are limited to 2.8 kilohertz bandwidth. So your phone signals and your digital signals in that band have to be limited to 2.8 kilohertz. And the CW signals, you're allowed to use CW, but only at the center frequency. This makes no sense whatsoever, but it's the rule. Only at the center frequency. So theoretically, you should only have one CW signal permitted per channel because everybody's supposed to use that same center frequency. So question E1A06 and E1C01 both have to do with what I just said. The required transmit frequency of a CW signal channelized operation in 60 meters is at the center, and the bandwidth for data and voice is 2.8 kilohertz. Now, there have been some changes in the rules that go into effect on February 13th. And I don't want to spend the time now to go into this, but you should look it up online if you plan to operate 60 meters, because as of February 13th, we're going to have another band of continuous frequencies, no longer channelized, where you can operate anywhere in this band. It's not all that wide, but it covers one of the channels that we used to have and more on either side. The good news is we have now this continuous frequency international allocation where we can operate without having to just be in the center for CW. The bad news is that new center has a power limit of around 8 and a fraction watts, which we'll talk about at some point, but not tonight. There's no questions on that on the exam because it's just coming out. So we lost one channelized frequency because it's in this new band, and we gained this new band of frequencies where we can go anywhere, but we're limited to less than 10 watts, whereas the rest of the channels still have the 100-watt limit that they always had. So um, that's in the process of happening right now. Only thing you need to know for the tests: 2.8 kilohertz bandwidth on data and single sideband, and CW only at the center frequency. That's 60 meters. Okay. We have these other bands we talked about, the 2200 meter band and the 630 meter band. These are some very low frequencies, 136 relatively, approximately 136 kilohertz. That's it, kilohertz. Is the frequency, for instance, on 2200. Now, we're very limited on how much power we can run. We're limited to 1 watt on the lowest frequency and 5 watts on the next higher frequency. Remember, after this comes 160 meters, which is a medium frequency band, and there we have 1500 watts. But here, we're limited to 1 watt effective isotropic radiated power, EIRP. This means if you have an antenna which has more gain than isotropic, which virtually every antenna will, then you have to back off your power so that you aren't emitting in any direction more power than 1 watt from an isotropic antenna would emit. Remember, a dipole has like 2.15 dB gain, so if you had a dipole, you'd have to back off by that much, 2.15 dB. However, that's not what happens here on this band.
How big would that be?
That big. Well, a half-wave dipole on 2200 meters would be 3,400 feet long.
30 foot, be more than a kilometer.
Yeah, more than a kilometer, and like two-thirds of a mile or three-quarters of a mile long. So nobody has that, and besides, it would be extremely low to the ground in terms of wavelengths, since to be a quarter wavelength up, it would have to be 1,720 feet above ground. So clearly, nobody can have that kind of an antenna here. Typically, the efficiency of antennas in this range is like 0.01%. That's actually not a bad efficiency in this band. Practical efficiencies range from 0.0033% to 0.013%. So you're still limited to 1,500 watts maximum output power. But it turns out that with a 0.067% efficient antenna, you would not be violating the 1 watt EIRP running 1,500 watts, because these antennas are extremely inefficient. Their radiation resistance is in the fractions of an ohm, in the milliohms. And of course, all of the resistances of loading coils needed, and the ground resistance and the cable resistance and all these things are much bigger than the milliohm resistance of these short antennas that have to be short because of the wavelength. So you actually need to run quite a bit of power to even have a 1 watt EIRP. So most people aren't running 1 watt EIRP on these bands. So what do you have to know? You have to know these two numbers: 2,200 meters, 1 watt EIRP, 630 meters, 5 watts. That's a 5, not an S. Five watts. Okay. Those you need to know. Now, another thing you need to know is that you can, believe it or not, operate phone in the 630 meter band. Now, there's not much room there, but you could get a phone signal in there, and it is permitted. Nobody does it because it would be very difficult to copy a phone signal because of the weak signals that you have. You'd rather have a narrow bandwidth to try to help you all you could to get better signal to noise ratio. But nevertheless, the rules do permit phone. It is permitted anywhere in that band. Of course, it barely fits, but
same for 2,200 meters actually. it's permitted. I don't know how you would do it.
Yeah. Question.
The
This,
question is only for 6:30. Yeah.
um, and if you want to operate here, before you can, here's a strange thing. You have to notify the Utilities Technology Council. Now, the reason is that the utility companies use power lines to send some signals in these bands. And if you're too close to their power lines that use this signaling, they won't let you operate. I don't know of examples where people have been notified that they couldn't. But here's the way it works. You notify them and you wait 30 days. And if you don't hear from them, you can go. In other words, they aren't going to take the trouble to answer you unless you have to not do it. So if you get no response, you may operate after 30 days. So if you haven't heard anything, you're go. All right, so that's question E1CO3. Notify the Utilities Technology Council. Who do you notify? The UTC. It doesn't stand for Universal Coordinated Time. The UTC, the Utilities Technical Council, of your call sign and station coordinates. And then they'll check to see if those coordinates are okay. Any questions?
Is that approval permanent? I guess it is.
I guess so. I mean, I suppose that if they didn't get back to you within 30 days, I don't know what could happen. I think they could probably shut you down if it was their responsibility to get back to you. But if they finally did get back to you and said you were causing a problem, I don't really know. You probably have to shut down. This doesn't happen very often at all, so don't worry about it, except to know it on the test.
Can you spell out the acronym or the abbreviation for EIRP, equivalent isotropic radiated power?
Remember, isotropic is something that transmits the same
Imaginary point antenna.
Yeah, it's the same up, down, back and forth. So every antenna that's real has some more gain than isotropic. Well, unless it's very inefficient, like these antennas over here are very inefficient. They would have some gain if they weren't so inefficient. If you could get the power into them, but you can't. That's the problem. Okay. So now I'm going to go to a new topic. And this is automatic message forwarding. So there are stations which are monitoring frequencies to automatically receive and relay messages digitally, and they're in the HF bands. And so the question is, suppose some message violates the rules, like it's illegal third-party traffic, or it's a commercial, you're doing business over the internet or something like that using automatic message forwarding stations. Whose fault is that? It's the responsibility lies with the originating station. It lies with the control operator of the originating station of that message. They're the one that put the thing out there. The person that isn't responsible for keeping the automatic messaging station working can't sit there all the time and watch all the traffic that goes through. So the FCC has said it's the person who originated the message who is responsible. That only makes sense, right? This is for these automatic message forwarding stations. And of course, if it's forwarded inadvertently. Now, if it's part of some kind of scheme, well, then all signals are off. But anyway, as far as this question is concerned, it's inadvertently forwarded, and it's the control of the originating station. Now, remember what the control operator is. The control operator is the person who is responsible for the station, who's the one who's responsible for making sure it complies with the FCC rules. There is always a control operator. There are several kinds of control. There's local control, there is automatic control, and there is remote control. Local control is obvious. The person is right there with the station, with turning the knobs, pushing the buttons. Automatic control, there is no person there. It's being done by computer or some other device, and there is a control operator who's responsible for it, but that control operator, he or she, is not at the control point. In remote control, there is a control operator at the control point, but the control point is not where the transmitter is. That is, you're working over the internet or over telephone lines. The internet, much more common nowadays, for remote control of stations. And that's being done a lot in the HF nowadays. And radios are coming equipped with the capability to do remote control even. So these are the three kinds of control. There's always a control operator, and the control operator of the originating station is responsible for any rule violation that may occur as a result of a message being handled by an automatic message forwarding station. Now there's another question about RACES, which is part of Part 97, and it stands for Radio Amateur Civil Emergency Service. It is a service within the amateur service. It was developed during the Cold War time, right after World War II, and it was set up so that amateur radio could provide communications during a civil defense emergency. The big key to RACES, as we pronounce it, RACES usually, rather than RACES, we used to say RACES. The big point that you have to remember is that in order to operate in RACES, you have to be certified by a civil defense organization. Notice this wording is even so a bit old. So you can't be in RACES unless you are certified by some civil defense, Homeland Security, Emergency Operations Center, EOC, or some fire department. Some official group has certified that you are a member. They use just amateur frequencies. It's actually amateur operators and amateur frequencies and amateur equipment. There are no specific segments. They can use all amateur frequencies. It's not just government channels. In fact, it's not government channels. It's not military affiliate radio system channels, MARS. It's all. So 2 questions about RACES. You have to be certified by the responsible organization for the area served, and you can use amateur frequencies, not any other, but any amateur frequency. Any questions about that? Now there's some rules about stations on ships and aircraft. What conditions must be met before operating a station aboard a ship or aircraft? The installation of the radio must be approved by the master or pilot. master of the ship, or the pilot of the aircraft. So you can't just operate aboard a cruise ship without having permission from the master to do so. On a U.S. registered vessel, so if the vessel that you're on, the boat you're on, is U.S. registered and it's in international waters, so here you're off the shore of the United States, you're not in United States territory, you need an FCC license. But that's all you need. There's no other special permit or anything that's needed, but that is enough. Is enough. The FCC license is enough to do it. Of course, you've also has to have gotten permission from the master or the pilot in order to do that. Who must be in control, physical control of the station, of an amateur station aboard a vessel or craft documented or registered in the U.S.? It has to be an FCC issued amateur license or reciprocal. So all of the rules almost everywhere say this, just to be thorough and cover the situation. You either have a license from the FCC or you don't have an FCC license, but you're permitted to operate by the FCC due to reciprocal licensing agreements that we may have with that country. So the key here, you'll kind of spot this question because it's the only answer that has this reciprocal licensing agreement in it. Anyway, who must be in control of the station? It has to be an FCC licensed person, not surprisingly, or the equivalent thereof, a reciprocal licensed person. So those are the three questions having to do with stations aboard ships.
There was a quick question for clarification. For stations on ships and aircraft, you have to have permission from the master to operate the radio.
Yeah, or to install, it actually says install.
You can sort of install it without permission, but you can't operate it. That's the way the question is written. It says, if it's installed, what must you have to operate it?
Okay. Yeah, I think it actually says the words in the, I have to look up the exact wording. But anyway, that's sufficient to answer the question. You have to have permission.
You have to have permission to operate it. So, I mean, and I've seen this. People take their 2-meter rig on board a commercial airliner and they start making radio calls. So technically it's installed, but you have to have permission from the pilot in command to operate. And he'll say,
and technically,
and he'll say no.
If you read your agreement, when you go on a cruise ship, it almost always says you can't have any amateur radio equipment on board.
Usually they don't allow it unless it's an actual ham radio cruise, which they've done those too.
Yeah. So, do people cheat? I wouldn't know.
No, never.
Okay. So, all right. Any questions about that? I'm going to move on. All right. We're continuing down the operating restrictions. This is a rule that I have not heard being enforced in any recent time, but it's in the rules, and that is what's sometimes called quiet hours. Suppose your station is of good engineering design. In other words, there's nothing wrong with your station, and it's still interfering with somebody. The FCC can require that you avoid transmitting during certain hours. And I'm not going to bore you with all of what the hours are, but they're like prime time TV hours and like Sunday morning church times, because there used to be some problems with in ancient days of PA systems in churches being interfered with by amateur radio equipment.
You didn't want to be transmitting while Peyton Place was on back in the day, right?
Right. So it's during certain times. So there's a question on that, just to remind you that that rule is still out there. You're also, of course, not allowed to have a spurious emission. These are not allowed. So what does that mean is the question. What is a spurious emission? That is outside the necessary bandwidth to send the information. Of course, the bandwidth is also limited by other rules, but outside the necessary bandwidth to transmit the information. And in other words, that the level can be reduced without affecting the info being transmitted. In other words, this is unnecessary bandwidth, signals that are outside the band that you need to send your phone signal, your CW signal. They're extraneous signals that can cause interference that don't add to your ability to get the message across. That's the definition of a spurious signal. It's not a signal with a spurious signal is not a signal that is not properly identified. It's not a signal meant to prevent detection of the station transmitting. It's not unintentional interference. Those are not the definitions of spurious. The spurious is signals that are outside the necessary bandwidth needed to transmit the message that you're transmitting. Okay, some more interesting rules that you have to know. And a lot of this is going to just require practice exams where you get used to these questions. You might want to drill on this section 1 where all the rules questions are a bit, because there's a lot of stuff that I'm going to try to give you ways to memorize it, but generally you're going to have to remember it because it's rules. They're not necessarily logic. There is a rule that you have to protect FCC monitoring facilities. And somebody always asks, how do you know where they are? I guess you can go online and find out where they are. But I'll tell you this, you'll find out where they are real fast if you start interfering with them. And that's within 1 mile. So this doesn't apply to very many people, but if you live within 1 mile of an FCC monitoring facility, the FCC can say, you're bothering us, you'll have to stop. No matter whether you're doing anything wrong or not. If it's just if it bothers their ability to monitor the band because your signal's so strong or whatever, they can make you stop. They're not arbitrary. I've not heard of this happening in any recent time either. We do have a FCC monitoring station down here near Washington, D.C. I don't know if there are any hams within 1 mile of it. The odds are there are. But in any event, E1B03 wants you to know it's within 1 mile of the FCC monitoring station that you have to protect it. They also want you to know what PRB1 is all about. PRB, I had to look this up. It stands for, I think, Private Radio Branch. The reason why I say think is Bureau, rather, Private Radio Bureau. I think because I found many references to this rule on the internet, and only 1 or 2 that had any definition of what PRB stood for. In fact, only one, and it said Private Radio Bureau, so maybe that's it. Anyway, this was a ruling by the FCC that's a good one for us. It applies to state and local zoning. It doesn't apply to homeowners associations. And it says they have to make a reasonable accommodation of amateur radio in their zoning rules. They can't just out and out ban amateur radio antennas and say, nope, none, we can't have any of those in this area. That's not, HOAs can do that, but state and local zoning cannot do it. They have to make a reasonable accommodation. And of course, you're probably going to have to go to court if they give you something that they consider unreasonable and they think it's reasonable and you don't. But at least you have PRB1 on your side, and you have the ARRL on your side, who loves to fight these cases, help you fight these cases because they've been successful many, many times. Now, this doesn't mean that you can put up a 200-foot tower in the backyard of your condo, but it has to be a reasonable accommodation. That's the word. Must make reasonable accommodations of amateur radio and regulations concerning antennas. If you live near a public use airport, which I do, and so does Tom actually, you may have to notify the FCC and the FAA. And in fact, if Part 17, like we're Part 97, Part 17 has the details of what you need to do. And the reason we don't have a detailed question on this is it's a complicated rule. It says depending on how far away you are from the airport end of the runway, there are different restrictions on how high you can have your antenna and so forth. So additional rules can apply that you need to look into if you're very close, within a few miles of a public use airport. Most of them have to do with the height of antenna structures, so that you're not putting up something which is going to cause an accident at the airport and planes taking off and landing. Okay, we're up to section 3.3 now, if there are no questions, on station control. And I already mentioned this. There are basically three types of control: local, remote, and automatic, which I've explained to you. If you are doing remote control, you have to have a 3-minute timer on the transmitter, so that if you haven't given any commands or if the link malfunctions, it will shut down all by itself within 3 minutes. So you have to have a 3-minute, essentially dead man switch kind of thing, that if the link gets broken, the transmitter just can't stay on and cause interference to other stations. So this is a 3-minute timer if the control link malfunctions. If you are telecommanding a station, now telecommand is like remote control. You're sending commands by internet or by radio to control your radio, and it's an Earth station. That is, it's not a space station. Now an Earth station is within 50 kilometers of the Earth's surface. So this is a rule having to do with not with commanding satellites, but telecommanding an Earth station, a regular ham station on the ground, essentially. Could be in an airplane too, of course. You have to, at the station, at the transmitter, since you're not there, you have to have some information. You have to have a photocopy of the license. You don't have to have this at home, but you do have to have it if it's remote. Then you have to have a label or a sign with the name, address, and telephone number of the licensee. And also of the control operator, which may be the same person, but maybe not. So all three is the answer to this question. What do you have to have at the transmitter of a station being telecommanded, Earth station being telecommanded within 50 kilometers of the Earth's surface? You have to have a photocopy of license and a label with the name, address, and telephone number of the station licensee and the control operator. If you are doing telecommand of a model aircraft, a model craft, I should say. So now you're not controlling your transmitter and receiver remotely. You're controlling a model plane, boat, car, whatever. Then you're limited to 1 watt. One watt. And I don't think that's an ERP number. That's just a output power, 1 watt. Generally, one-way transmissions are prohibited. In other words, broadcasting is prohibited. One-way transmissions, can't spell, are generally prohibited, but there's an exception for space stations, that is satellites. Beacons, of course, beacons have other restrictions on them, but they are permitted since they're not waiting for anybody to talk back. And telecommand stations, because obviously you're not in QSO with anybody when you're telecommanding something. So if you have a radio link that's controlling a radio controlled craft, or your radio link is used on your repeater or something, these telecommand stations are one-way transmissions that are permitted. But other than that, there are no one-way transmissions permitted. Again, these rules up here about telecommand apply only. These particular rules we're talking about are for Earth stations, not for space stations. Any other questions?
Yeah, before you change screens, could you pause for a second? Some people want to do screen captures. And that's all. I'm still filtering some of these questions, so I may feed you a couple more.
Okay. So let's talk a little bit more about automatic control. Specifically, the control operator need not be present at the control point. He can be at home asleep, can be at work, whatever. There's always a control operator, but he need not or she need not be present at the control point. This is question. This by the way, I just said this. This used to be a question. It's no longer a question because I think it's already on another exam too. So I think there's something in the book still about it, but there's no question on it anymore. When may an automatic control station transmit third party? That is, you remember what third party communications are? Those are communications for somebody besides a person eligible to be the control operator of the station. So if you're transmitting for somebody who doesn't have a license, essentially, to operate in the bands and frequencies you're on, that's third party. Typically, we're talking about messages for some non-ham, but it could be for in the extra class part of the band for a general class ham. Would be a third party communication in that case. In any event, if it's under automatic control, auto control third party traffic has to be RTTY or data. This is all through the amateur radio rules, part 97, it'll say RTTY or data. We would call it digital signals generally. You can't have an automatic control station doing third-party communications on phone and CW. It can only be digital requirements. When may a station under automatic control transmit third-party communications? Only RTTY or data. There's also a question about telemetry. What is the definition of telemetry? It is a one-way transmission of measurements. It's a one-way transmission, so it's telling you what's going on somewhere else, of measurements. At a distance from the measuring equipment. So telemetry is, and if you had some device at your repeater measuring the temperature of the environment that the repeater was in. If you had a satellite with monitors of battery condition and power output and so forth that's sent down to Earth, then that is telemetry. One-way transmission of measurements at a distance from the measuring equipment. Specifically, if you have balloon-borne equipment, and this is something that's quite often done nowadays, balloon-borne telemetry stations where you're using amateur radio to monitor altitude, GPS position, and that kind of thing. What's the ID requirement? Well, it's just the call sign. Well, I say just, I mean it is the call sign. You're not exempt from call sign ID, but you don't have to do anything more than that either. So a Morse code ID of the transmitter is adequate to identify the transmitter if it's a telemetry station transmitting amateur radio equipment. Of course, it has a control operator too, the person who takes responsibility for it. Any questions?
Yes, many.
Oh gosh.
So let's start with the balloon. Whose call sign does the balloon use? I guess
Whoever the control operator is.
Whoever owns the station.
Yeah, probably. I mean, this thing about whose call sign you use is not so rigorous as you might think it is. If Tom wants to put up a balloon and I want my call sign on it, but I'm saying, Tom, you have to be the control operator, well, then that's fine. He says, okay, I'll be the control operator. So he's the control operator. It's my call sign. As long as I've designated him as the control operator of my call sign. Personally, I don't know why you care about this.
Yeah, there's a lot of things that just don't matter. And just stick to the question. We could get all wrapped around the axle about balloons, and there's something else. I don't know what you said, but something about data transmission.
RTTY and data.
I have about 5 questions about CW
Is
being
that data or digital or not? It's not in FCC's rules. FCC rules, there's CW, there's phone, and there's RTTY or data. And it's always these two together, RTTY or data. They all the RTTY and data have the same rule. So it always says RTTY or data in the rules when it's referring to digital stuff. And then CW is not called RTTY or data. Even though it's kind of digitally, but it's not.
but it's not from the rules. Okay, thank you. And somebody asked me about the CW portion of the band. That red band on those charts you're looking at is the RTTY and data area of the band. CW is authorized everywhere.
Yes. All amateur radio bands allow CW everywhere. Well, except that, that's
Channelized
meters. You have to be in the middle of the band, but
be in the center. But except for that, so that when you look, and I'll look at those charts later when I do the review probably, but that red part on the lower part of the band is for RTTY and data. CW is authorized everywhere. And CW for rules purposes is not data.
that is correct. Anything else?
Uh, got one more balloon question. How often you have to send the
Every 10 minutes and
right?
same rules.
Same rules.
Every 10 minutes and at the end.
Okay, that's about it for now.
So these are some special rules having to do with the amateur satellite service. First, space telecommand stations. These are the stations that control the satellite. What is one? Well, it is a station which initiates, modifies, or terminates the functions of a space station. And a space station is a station above 50 kilometers. Essentially, it's a satellite. If a balloon got above 50 kilometers, it would be a space station. I don't think they can go that high, but maybe close. I don't know. Anyway, telecommand means initiate, modify, or terminate functions. And a space telecommand, of course, initiates, modifies, or terminates functions of a space station. That's the definition of a space telecommand signals. And why do I mention that? They may be encrypted to hide the meaning. Generally, you cannot encrypt things to hide the meaning, but you can do that for radio control of models and space stations. Well, obviously, you don't want somebody to be able to take over your satellite and command it to do things you don't want it to do. So the rules specifically exempt telecommand signals for space telecommand from the encryption rule. More satellite rules. Which amateur stations can be a telecommand station? Well, it's pretty obvious. It's whoever is designated by the licensee. I guess it's whomever the the space station licensee designates. Remember, the space station is the station out in space. So, which stations can be telecommand stations? It's logical. Whoever it is that has the space station can say who can be the telecommand person. Give them the encryption keys and equipment that's needed to do that, or how to build it, or whatever. So which bands can be space stations? This question's a little less clear than I would like it to be. It's 40 meters and higher frequencies. That's 7 megahertz. And higher frequencies. That's like 30, 20, 15, 10. But funny I should mention 30, but not 30. There's no space stations permitted on 30 meters. The question does not contain 17 and 12 meters, but as far as I know, there's never been a space station, a satellite transmitting on 12 and 17 meters. So we decided, yeah, the question should probably include 12 and 17, but it's never been used, so why bother? Actually, I don't think there's been one on 20 meters either. But the answer is 40, 20, 15, and 10 HF. Which HF bands can be used by space stations? What about VHF? On VHF, it turns out it's just 2 meters. And on UHF, it is 70 centimeters, that's 450, and 13 centimeters. So, I mean, there's not too many VHF bands to choose from, but there's no 6 meters and there's no 220. 2 meters only. UHF is only 70 centimeters and 13 centimeters. Which licensees can be Earth stations? Let me change the colors here. This is a very obvious question. I think you would think it would be obvious. You sort of have to know the terminology. Who can be an Earth station? Now, first of all, what is an Earth station? Well, Earth station is a station communicating through the satellite from the Earth, by definition at 50 kilometers or less above the Earth's surface. And who can be? Anybody within their privilege. Of course, they aren't given special privileges for this. They have to be within their privilege. Who can be the control operator of a Earth station? Anybody who's got privileges to operate in the band that the satellite is in, or that the space station, is the words they use, are in. So that's what to kind of get used to this terminology: space station, Earth station here. Any questions about that?
Not yet.
Not yet. Okay. Good. Glad to hear that. Okay, now we're going to be talking about the volunteer examiner program. And there are quite a few questions on this, because as an extra, you're going to be able to do be a ways of doing that. Let me stop this. So VEC, well, first of all, VE, that's a volunteer examiner. And the volunteer examiner is certified by a VEC, which is a volunteer examiner coordinator. There are 14 of those in the country. And the biggest ones, ARRL, W5YI, Laurel, those are the three top ones. But there are 14 altogether. Some of them are very, very, very inactive. A few are very inactive. These are.
What did you say?
There's another organization.
Very inactive?
Yeah.
Okay.
One or two of them give very few, if any, exams. There are several of them that only give a handful of exams a year, and there are others like W5YI and ARL and Laurel that give thousands of them. So almost all the work is done by three of them, and some of them hardly do anything. Only a couple. Anyway, there's only 14, and that's the VECs. That's the Volunteer Examiner Coordinator. There's another group called the National Conference of Volunteer Examiner Coordinators, and this is where these 14, although two of them never show up, get together to put together the question pool and do other things for mutual benefit of the Volunteer Examiner Coordinators. But the only thing they're required to do by the FCC is develop a common pool. And as you know, I'm the chairman of the NCVEC Question Pool Committee that writes the exams. We're currently just finished the tech, and we're getting ready to start on the general. Okay, so volunteer examiner coordinators, you need to know those two. What is the VEC? It's an organization. That's the clue. It's an organization that entered into an agreement with the FCC to coordinate, prepare, and administer amateur radio exams. I'm not going to write all that out. VEC is the organization, the coordinator. The volunteer examiners are the ones who actually do the examining. The VEC accredits VEs. They're the ones that decide who can, who meets the FCC requirements to serve. So the VECs, if they say you're a VE, you are. If they don't, you aren't. You could be accredited by any of these 14 coordinators. They use different techniques. There's no requirement by the FCC of how they do this accreditation. The one I belong to is Anchorage Amateur Radio Club. I've never operated in Alaska, but nevertheless, that's the VE that I'm associated with. And the Anchorage group has an open book exam that you have to take in order to become a VE. Some of them just do on-the-job training. So they have different techniques for how they accredit their VEs. They also have to make sure that they have the proper licenses and that they don't have other issues that would prevent them from, like having a license that's been revoked and that kind of thing, which would prohibit them from being VEs. So they got to meet the requirements, and that's one thing for sure. VEC does is they want to see your license and check you out, make sure that's all okay. So the VEC is tasked also. They're tasked with maintaining the pool. And they do that through the Question Pool Committee, but that's their determination, not the FCC's. So they have the three pools, and all of the VECs have to use this one common pool. So there are two questions about that. Let's see. A VE cannot administer to a relative. Tom had had to excuse himself when his son and daughter were taking the tests because he was one of the VEs, but he couldn't administer the test to them. Somebody else had to do it. They don't ask you this, but somebody's bound to want to know. Who is it? Spouse, children, grandchildren, stepchildren, parents, grandparents, step-parents, brothers, sisters, step-brothers, step-sisters, aunts, uncles, nieces, nephews, and in-laws. That's what the definition is of a relative according to the FCC Part 97-509 that says VEs can't administer exams to that relationship. VEs are allowed to be reimbursed for expenses. Now, what expenses can be reimbursed? In other words, they charge the people taking the exam. What can they charge for? Preparing the exams, that is, putting together the specific exam from the question pool, processing all that paperwork that's needed, and submitting that stuff to the FCC, administering and coordinating. So these are expenses that they're reimbursed for. They're not allowed to make a profit. But any costs that they incur can be reimbursed through fees that the FCC generally publishes a number of what that can be. They can, parenthetically, it's not, you can't be reimbursed for teaching or what's the other one that's in there? Providing training material. These are not functions of the VEC to do teaching and training. They may do teaching and training as the same people, but that when they're VEs, they are not being doing teaching and training. They're doing all this stuff about administering, preparing, processing, coordinating the exams, and they can be reimbursed whatever the costs are for that. Laurel does not charge anything. They individuals cover their own travel expenses and paperwork and pencils and papers and laptops and things that they use. They just do it. They're the only one now currently, I believe, that doesn't charge anything for administering the exam. So if you want to take an exam and not have to pay any extra, Laurel is your group, at least for now, and it has been for a long, long time. These are out of pocket. Not, well, I get $3 an hour, I'm going to charge. No, that doesn't count. Okay. More VE questions. Who is responsible? This is a kind of a gimme. Who is responsible for proper conduct of the exams? And the answer is each administering VE. It's not the section manager. It's every VE present and involved in the process of administering the exams. What do you do if a person fails? You return the person's application to him. So nothing needed to be done to record the failure, although most people do keep track of it, but there's no requirement. You just return the application to the examinee. If they pass, what do you have to do? Well, 3 VEs have to certify that the person met the requirements. Three examinees, um, three VEs certify the examinee's qualification for license grant and that they have complied with the administering VE's requirements. There's no photocopying of documents and sending them to the FCC. They don't issue a license or upgrade right there. Neither of those two things happen. They keep all the records. The VEs give them to the VEC. VEC does not send them to the FCC. I think they're required to keep them a year. I'm not sure about that, but I think that's right. In any event, there's no question on that. What's the penalty? If you're a fraudulent voluntary examiner, you could lose your license. So a penalty for, let me see the exact words, fraudulence, penalty for fraud by a VE. You could, revocation of your station grant and suspension of your amateur license. So you could lose your license. And they always talk in the FCC rules about the license station grant and the operator license grant as if they're two different things, but they really aren't. It's just one thing. But they always talk about them as if there's two different things. So I guess technically there are, but you don't get a separate station license and a separate operating license. You just pass the test and you have a license for both. If it's successful, if the applicant is successful, what do you have to do? Well, they have to submit to the VECs, submit applications to the VEC, not to the FCC, but to the VEC, according to that FCC, according to the VEC's instructions. So whatever system that the VEC is set up for how you do that, the FCC doesn't get into how you do that, but they don't get the paperwork. What happens is that the VEC has somebody who will go online to the FCC database and enter the information about who's passed the test, and all their data be entered in that way, and then they'll appear on the website. Any questions? Okay, I think it's time to take a break. We are getting near the end of the rules questions, and then I'm going to start into some math stuff, which I will complete next week. But this is going to be kind of an introduction to mathematics that you need, or that you might find useful. Let me put it that way, because you may not need it depending on how you approach the questions. I don't want you to get hung up if you think you'll never learn this math stuff, because we're going to help you get around that. But we think you ought to have some exposure to it, and maybe it'll be helpful to you too. Hopefully it will be. Okay, so let's take...
Yeah, let me say one thing before you go off. I must have 50 questions in here about being a VE and so forth, and it's kind of I'm trying to answer them, in the chat window. But it's kind of way outside the scope of the exam questions. If I can just summarize real quickly, different VE groups, testing groups, have different sets of rules. So I can't globally say that they will tell you your score or tell you how many you got wrong or which questions you got wrong. Generally, my experience has been that most groups will tell you how many you got wrong, but they won't tell you which questions you got wrong. A lot of it is about efficiency as opposed to regulations. So, you can check with the individual group. If you're well prepared, you go in and you pass the test, then you don't care about all that stuff. So but it is not strictly covered by rules. So different groups have different policies. Other than that, like I said, I'll try to answer some of these little specific questions in the chat. If you have questions about the testing process, you should probably figure out which group you're going to go to for your test and contact them and see what their policies are.
And there's some links to the places to get that
In the
information
syllabus.
in the syllabus. And when the syllabus is sent to every one of you, but if you can't find it, it is online. It's linked at the same tiny URL site everything else is.
Yep.
All right, let's take till quarter after.
All right, I'll pause the recording here. I think I paused. Okay, go ahead.
All right. So let's pick up where we left off. We still have some rules left to go here. We're finally finished with the VE rules. So now we have some, as if these weren't pretty miscellaneous. Now we have miscellaneous rules. So that they ran out of ways to try to group these, I guess. So there are these things called auxiliary stations. Auxiliary stations. What are they? Well, they're stations that are used not for direct ham radio communications, but point-to-point communications within a system of cooperating amateur stations. I'm quoting their thing. Auxiliary stations are point-to-point communications within a system of cooperating amateur stations, such as between a remote station and a control point, or links for repeaters. In other words, these aren't stations that in and of themselves you talk to, but you may talk through them or command your station through these auxiliary stations. So now that you know what an auxiliary station is, who may be the control operator of an auxiliary station? Well, there has to be one. It's any class license but novice. There are still a few novices out there. They cannot be, even if they have privileges on the band that is in use, they can't be a control operator. This is a pretty obscure rule, but after all, it's the extra class test, so I guess you should know these kind of things. How about external power amplifiers? They have some rules. These came about back in the CB boom, primarily, where illegal CB operators were using ham amplifiers, and they wanted to try to put some kind of control over it. There's such a thing as FCC certification of amplifiers, of external power amplifiers. So they have to, people who are manufacturing these things have to submit their amplifiers for test, and they have to meet all the spurious emission requirements at 1500 watts or the max power output, whichever is less. Now, why would it be worded this way? Well, for instance, I have an Expert 2K linear here. It's rated for 2 kilowatts. I've never had it at 2 kilowatts, so I don't know. I assume it will make it there, but I'm not going to try. But it doesn't have to be tested at more than 1500 watts, because that's all we're supposed to ever use it for. And of course, if it doesn't go to 1500 watts, obviously you can't test it at that power. So whichever is less, its maximum capability, or if it's capable more than 1500 watts, you don't have to do it at more than 1500 watts. So that's the rule for certification. Lots of other distractors sound good on this question, but the right one is the essential ones, and there is no all these. So the right one is that it has to be certified at 1500 watts. maximum power or maximum power output, whichever is less. Now, when can a dealer sell an uncertified amplifier capable of operation below 144 megahertz? This is the rule. There's no restrictions on higher frequencies. Below 144 megahertz, that is below 2 meters. If it's capable of that and has not been granted FCC certification, can they sell it? Yes, if it was purchased used and resold to another ham. For use in their station. They're trying to get around resale or anything. So they're saying, hey, if the dealer got this thing used from somebody and it wasn't FCC certified, well, he can resell it as long as it's to another ham. However, if he's buying it new, then he's got to be getting it from a manufacturer who has certified it in order to sell it. That's implied by this. Any questions about these rules concerning external power amplifiers? Just two things. Test them at the max power or 1500 watts, and dealer can sell ones that aren't type certified by FCC if they're used and resold to another ham. Okay, now there's this line A business. And line A is a line that is they're on both sides of the border between Canada and the United States. It's roughly parallel to, line A is on our side, roughly parallel to and south of the US-Canada border. If you want to see it, it's on page 321, figure 3.5. But it is a line on the map that's specified in the regulations rather thoroughly. And if you live up in the northern part of the country, near the Canadian border, stations north of line A in the United States, U.S. stations north of line A, can't transmit. They're not permitted to transmit in the 420 to 430 megahertz frequencies. That's because the Canada has assigned these frequencies to the fixed and mobile service, and the U.S. FCC has agreed to protect those stations by not letting amateurs operate in 420 to 430, because that's assigned to the fixed and mobile services in Canada, and if you're that close, you could possibly interfere with other stations. There's a line B in Canada side, has its own regulations we don't need to know about. The 440 to 450 is a possible wrong answer that you need to be aware of. It's 420 to 430. Try to remember that, 420 to 430. Okay, another question is, what is the national quiet zone? Well, this is to protect radio astronomy. And radio astronomy uses radio frequencies to look at the universe, and they can get very high resolution, even higher than optical, by using multiple receive sites that are phase locked to one another, and they can get the highest resolution from these radio astronomy observatories. This national quiet zone protects our National Radio Astronomy Observatory, which I think is in West Virginia. and you're not supposed to have radio equipment in that area installed. You can drive through it actually, but you can't and transmit on your mobiles. But you're not permitted to install without permission radio transmitters in that area. And here's some questions about business communications. You can only communicate with businesses. You can communicate third party with businesses if no pecuniary interest, that is, pecuniary means money, in the communications. So if you're making some money as a result of this communication, either at either end, this is not permitted. Other than that, you could. So this has been called the order a pizza clause. Back in the heyday of repeaters, which is long past, auto patches, which is long past, people had the ability before cell phones to use their 2-meter radios through repeaters to make telephone calls. And the question was, could they order a pizza? Was that doing business? And they said, yeah, you're not. That's okay. You're not doing that for money. They didn't consider buying a pizza, making money on the deal. Anyway, when neither have a pecuniary interest in the communications, and it sounds to me kind of like selling a pizza would, but believe me, pizzas are okay, as if that matters anymore, because people just pick up their cell phone. They wouldn't bother to go through an auto patch on a repeater. Anyway, E1CO2 wants you to know that you can't do communications with businesses. That means you can't call in on your way to work and say, I'm going to be late, using your ham radio, as if you would do that anymore. But that was a point at one time. How about communications with foreign countries? So what are the restrictions there? They have to be incidental to the amateur service. So it has to be things that hams normally do, as be putting it another way, and remarks of a personal nature. These are permitted. They don't have to be both at the same time. They have to be one or the other or both. So you can have personal discussions with other hams. You can do things that hams generally do, work DX and give signal reports and all that kind of stuff. That's all great. But you can't go beyond that. That doesn't mean you couldn't discuss politics with them if you wanted to. I guess that would be okay. But you can't do anything that even comes close to doing business or passing traffic or that kind of thing, unless we have a special agreement with that country. So communications with foreign countries are limited to incidental to the purpose of the amateur service and remarks of a personal nature. There is no exception for nonprofits. That's part of the question. There's not. If it doesn't matter that it's nonprofit, if it's doing business, it's not permitted. And maritime satellite service has nothing to do with it either. Those are two distractors that you want to be careful of. So if there's another question that says, which of the following is prohibited? And what is prohibited is comms for hire or material compensation. It's very broad. Any kind of material compensation. It doesn't have to be money. Could be giving you a free ham radio, or even theoretically a T-shirt, although nobody cares about that if you get a T-shirt for helping out with the parade. So let me finish this. Material for hire or material communications for hire or material compensation are prohibited, except as else spelled out elsewhere. I'll just put except. And the exceptions are things like if you're a teacher and you're using ham radio as part of your teaching and you want to operate and you're still being paid during that time as well, that's okay. And people that are in emergency communications centers and they're using amateur radio and they're having a practice drill but they're being paid, that's okay too. There are some specific exceptions, but generally comms for hire material compensation are prohibited. Spread spectrum, and this is where Tom will tell us about Hetty.
All right.
You got her picture there as usual?
I was all fired up, and now, where is it? And here she is. Seeing that?
Yeah, see Hetty there.
Okay. There's Hedy Lamarr, one of the most beautiful actresses in the world. So during World War II, Hedy Lamarr, along with H.K. Markey, who I think was her musical arranger or composer, filed a patent for a technique for what's called frequency hopping or spread spectrum communication. The invention, the concept was developed in conjunction with control of torpedoes during World War II by radio, and to provide a system that couldn't be interfered with or jammed or misdirected by the other side. So unfortunately, since she was not a U.S. citizen or U.S. national, as soon as the patent was issued, they classified it, and she wasn't allowed to see it and wasn't allowed to get any credit for it. But many, many years later, probably in the 70s or 80s, she was actually recognized for the invention.
She was elected to the Inventors Hall of Fame.
So look up Hedy Lamarr spread spectrum, and you'll learn there are many, many papers written about it, and a lot of recognition for kind of after the fact.
So what spread spectrum is, the idea behind it is that rather than transmitting on one frequency, you transmit on multiple frequencies. And there are two ways to do it. One called frequency hopping, where you constantly change frequency and the person at the other end knows the pattern that you're using to change frequency and changes along with you. So this is called frequency hopping. And in those days it was done very slowly with relays, but nowadays it's done extremely fast digitally. And in fact, so fast that it just kind of causes noise all over the band if you don't know what you're listening for. Although I have heard some frequency hopping stations that are relatively slow. Anyway, that's called spread spectrum. It's used to avoid interference, but it's also used sometimes for secrecy. Hams are permitted to use spread spectrum, and in fact it is part of the Wi-Fi system, and many phones in your, if you're in your house you have a wireless phone, they use spread spectrum too. It allows multiple people to be on the same frequency at the same time without interfering each other, or same frequencies, because they're jumping around or spreading. I didn't mention the other way. The other way of spreading it is to mix the signal with a digital, high-speed digital signal, which spreads the spectrum in a pattern that if you know the spreading function, you can unspread it at the other end and get the information back out again. So hams are permitted to do this. They're limited to frequencies above 222 megahertz. That's the question that's on the exam. No spread spectrum below 22 megahertz. 22 megahertz or up.
220.
220. Whatever.
Is it 222 exactly?
222. That's the low end of the 220 band. Well, not the low end. There's that little funny part at the low end that's used for auxiliary stations. Anyway, it's below 222.
It's not permitted. So actually, the answer in the test says only on frequencies above 222.
Okay.
So
yes, restricted to above,
222.
not below. Yeah. Okay, now another again, we're shifting. These are miscellaneous rules. So the SEPT agreement. This is a abbreviation for a French term for telecommunications. The European Union Telecommunications Office, and there's an agreement between the EU and the United States that hams can operate in the SEPT countries in the EU. They have to have an extra license to have full privileges there. That's not on the test. What is on the test is that they have to, this is really ridiculous, but this is it. They have to have in their possession a copy of the publication, this one sheet of paper, this FCC public notice that says that there is such a thing as SEPT agreement, essentially. It's an FCC notice, and it's DA 16-1048. We had to change this because they came out with a new one a couple of years ago. So here's the scheme. You know, you're operating from France, or it's the EU, and you don't need to do anything ahead of time. You got your radio over there. You got your extra class license. You're operating on the bands there, portable F in France, and the French the gendarme come up and they say, "Monsieur, I'd like to see your copy of DA 16-1048, please, monsieur." And so you whip it out and say, "There." Oh, and they say, "Oh, good. I'm glad you got it, because otherwise I'd have to shut you down." I cannot imagine, anybody knowing this. I can't imagine why they would need to see a copy of the FCC notice, but nevertheless, that, believe it or not, ladies and gentlemen, is the rule about operating in SEPT. It's crazy in my opinion, but hey.
Well, it's probably some treaty that somebody signed.
Probably somebody who
years ago and never rescinded it.
Yeah, it stands for the European Conference of Postal and Telecommunications, I guess. But so that's the SEPT agreement in the EU. In South America and Central America, we have another agreement of sorts. It's called the IARP, the International Amateur Radio Permit. So this is something you have to get, and not every country in Central and South America allows this to be used, but some of them do. You go to the ARL site, it'll tell you all you need to know about getting your IARP permit to operate in South American countries. I don't know which ones do it and which ones don't, so don't ask me. But they don't all. I know that because I have a license to operate in Antigua. My call sign is V26RA, and I can't use an IARP. I have to pay the Antiguan government for my license. I think $50 every 2 years or something like that. And so there's not an IARP with everybody, and it's not like the SEPT agreement. You do have to fill out the permit, and I don't know that there's an approval system for it. Anyway, if you're interested in doing it, go online to ARL for the IARP. It's not the AARP. I think that may be a choice. It's the it's the IARP for Central and South America Reciprocal Licensing Agreement. So you are also allowed to operate in Canada. So we have an agreement with Canada. You don't have to do anything special. You can operate from Canada, but you have this kind of a rule. You have to have a Venn diagram here. This is the Canada rules, and this is the U.S. rules. I'll use K for U.S. And this is the intersection of the two. This is where you're permitted to operate. In other words, you can't operate outside of the privileges for your U.S. extra license. You can't have any more permission than the U.S. extra license, nor can you have any more privileges than the Canadian license provides. So it's actually bigger than this. It probably should be like this. Mostly it's the intersection between the U.S. extra and the VE license. This intersection here is where you can operate. You can't get any privileges that you wouldn't have with the extra. You can't get any privileges that you wouldn't have with the VE license. Any questions about that? It's E1FO2.
There is a question about the CEPT or SEPT.
Okay.
Do you have to have an extra class license to operate in those countries?
No, but if you don't, you can only operate like repeaters. You can't operate HF. In order to operate HF in SEPT countries, you have to have an extra.
Or advanced?
No, I think extra. I'm not sure about advanced.
Could be if people are carrying an advanced license, they might be eligible. What I'm looking at here.
You have to look at the rule reference.
We'll have to look that up. Somebody
question.
else said they looked it up and it said yes.
Advanced or extra?
Advanced or extra.
Okay.
But I would double check that before you go and do it.
Okay, what else? What other questions?
That's all I see so far.
Oh, good. I mean, I'm glad to answer any questions that come along, of course. Always like to have questions. All right. So, let me try purple. You haven't had any much purple this time. This is the last question. Special temporary authority, or a STA. So these are issued by the FCC for experimental communications. And experimental amateur communications, often they issue a special license with an X in the cost, like W3XAA, something like that. For instance, when they were getting ready to issue rules allowing the real low frequency bands there at 22,200 and 630 meters, they for a while that they had a few people that had applied for a special temporary authority to operate in those bands, and the FCC wanted to see whether there was any problems or issues or how effective it was, and to gather some data. So they do this from time to time. They'll issue special temporary authorities, giving privileges that are not normal, but they're only given to specific stations with specific call signs, usually not their own. So usually special X prefix, X, I don't know, it's not a prefix, the suffix starts with X. So the question is, when may the FCC issue a STA to provide for experimental amateur communications? Question E1F06. So I think I have finished all of the questions about the rules and regulations, and I am prepared now to start off talking a little bit about mathematics. Are there any questions before I do?
Hang on. Couple quick questions about reciprocal operating. How about Mexico?
How about Mexico?
What do you need to do to operate in Mexico? Do you remember?
I don't.
When operating in a SEP country, you use your own call sign, right?
Yes. Portable in the country that you're in.
Portable with so you would be K3RA/G or something.
Right.
All right. No, that looks like it. I'm going to go through them and see if I missed any, but I think go ahead and hit the chapter 4.
Okay. I'm going to go more basic than they do in that one page, or maybe there's one inset page and then there's another page that is also about math. My plan is not to get into imaginary numbers tonight, but to do that next week. But we'll see how far we get. First of all, I just want to talk about equations. This is fundamental stuff, but I think we want to make sure everybody's on the same footing about what is an equation. So here's an equation right here. This is Ohm's law. It says that E equals IR, where E is the voltage in volts, I is the current in amperes, and R is the resistance in ohms. You know Ohm's law, and you know that these things are called variables because they can take on various values. They're called variables because they can vary. However, this sets a rule for how they can vary. They can only vary such that the voltage is equal to the current times the resistance. These two equal means that whatever value this is, the product of I and R has to equal the same thing. Now you can always do things to both sides of an equation as long as you do it to the entire complete side of the equation. When I say do things, you can perform operations. So what are the operations? Well, they're arithmetic type operations like plus, minus, multiply, and we also use a dot for multiply, and sometimes no space means multiply. I'll show you an example in a second. And divide, we very rarely use that signal. Normally we use the slash mark. Also raised to a power, like squared, like some number squared, or a root, like the square root of some number. And if there's nothing in here, the 2 is implied, but you can have the cube root. So I'm going to talk about what these mean if you don't remember in a minute. Just let me just say that E equals IR, this means I times R. Notice there's no space in here. I could also write it E equals I dot in the middle, or not down at the bottom, but dot in the middle. Another way of writing E equals I times R. And a third way of doing it would be I XR, but we usually don't do that because X could be a letter as well as that would be representing some variable. So we generally use either the dot or nothing at all to represent multiplication. So we can, whatever we do to one complete side, any one of these operations, we must do to the other to keep the two sides equal. If we add something to the left side, we have to add that same thing to the right side. If we subtract something, divide something, multiply something, we have to do it to both sides. If we can square one side, we got to square the other side, the entire other side, not just some part of the other side. So that means our little chart here which we use for people who don't know any algebra at all, EIR, which says that E equals I times R, I equals E over R equals E over I, comes about from what I just said. So if E equals IR is the Ohm's law, and that's generally how we say it, voltage equals current times resistance, we could also divide both sides of the equation by I, and if you have the same multiplier in the numerator and denominator, those would be a ratio of 1, so we could cancel those out, if you will, because I over I is equal to 1, so that doesn't change the value of R. So then we have a new version of this equation. We can switch the sides and say R equals E over I. We did this by dividing both sides of the equation by the same thing. So we can always perform any operation on an equation. On one side, we perform it on the same side, and oftentimes it involves multiplying the same or dividing both sides by something to move variables from one side of the equation to the other. So here we have R equals E over I, R equals E over I. It's that form. We can also divide both sides by R. E equals IR, divide both sides by R. It's very sloppy. One thing that's important is to be neat when you're doing math, or else you get yourself in real trouble. IR, remember this is a multiply, and if we divide both sides by R, well then the R's cancel, and then we have I equals E over R. So these are some fundamental manipulations of equations. We could also add things to both sides. If I add 10 to this side, I add 10 to the other side. I don't know why I'd want to do that in the case of resistance, but if I do add something to one side, I have to add the exact same thing to the other side, to the entire other side. Now, parentheses are important because they group things in mathematics. So two numbers like 3 plus 2 are grouped together. So if we say that's multiplied by, say, by 4, well, that 4 multiplies everything here together. It multiplies 4 times 5. That's equal to 20. It's also, you can spread this. You can say 4 times 3 is 12, plus 4 times 2 is 8. And of course, that equals 20. So when you multiply times something in parentheses, you have to do it to everything inside the parentheses. If you square it, you have to square the entire thing in parentheses. The thing in parentheses is grouped as if it is one number. So that's what we mean when we put parentheses in things. You should be familiar with all that. And now, what about these things called roots? Well, the square root of a number is a number which, when multiplied by itself, equals a number. So square root of some number, x, means a variable, any number, times the square root of x is equal to x. That's the definition of the square root. A number, when multiplied by itself, equals that number under the radical, as it's called. Radical is from the Latin word for root, by the way. So a square root is implied if you see nothing. If you see a 3, that means it's a cube root. So the cube root of x times the cube root of x times the cube root of x is equal to x. The cube root is a number which, multiplied by itself 3 times, equals the number. So we have exponents which indicate how many times we multiply something by itself. X squared means x times x. X cubed means x times x times x. And by x, this means any value. That could be representing any number, but it's got to be the same number. All x's are the same number. It could be any letter. It could be y. It could be z. It could be b. It could be any number, but it's got to, wherever you see the same letter, it means that's the same number as all the other letters of that variety. And it could be any number. Any number could fit into there. Any number squared is equal to that number times itself, one time, two times. 3 times is cube. Now what if we multiply the same number, x, by another number raised to the power, x squared times x cubed? What does that equal? That equals x to the 2 plus 3. Put parentheses to make it clear. X, and by the way, on calculator too, you should always use parentheses if you're in doubt to make sure that you keep numbers that are supposed to be grouped together. So x to the 2.3 equals x to the 5th. Why is that true? Well, x squared is equal to x times x. X cubed is equal to x times x times x. So this is x times x times x times x times x equals x to the 5th. It's pretty obvious. Something multiplied by itself 2 times something multiplied by itself 3 times is a total of 5 times of multiplying. So when we multiply, we add exponents. Now, what about if we divide? Well, what's x to the 5th divided by x to the 3rd? Let's look at that. That'd be x times x times x times x times x divided by x times x times x, right? Well, we can cancel these 3 x's because they're multiplied in both the numerator and the denominator, and that ratio is 1. It leaves us with x squared. What we've essentially done is subtract 3 x's from 5 x's here. So this is equal to x to the 5 minus 3, or x squared. So when we divide, we subtract exponents. All this should be pretty familiar. Maybe not, but for most of you, I'm sure it's very familiar. Okay. Any questions on that before I click to the next frame?
So far, so good.
Okay. Okay, so the next thing we want to do is what about negative exponents? Like x to the minus 2. What in the heck could that mean? Raise something to the minus 2? What does that mean? Well, it sounds funny, but we're just going to use the rules I just made up here. I didn't make them up. I told you about them. Let's say we had x to the 3 divided by x to the 5th. Then that is x to the 3 minus 5. By our rule that when we divide, we subtract the exponent of the denominator from the exponent of the numerator. So this is equal to x to the minus 2. But that's also equal to x times x times x divided by x times x times x times x times x. That's x to the 5th. And these will cancel out to 1. And so this is 1 over x squared. This is x times x, so that's x squared. So x to the minus 2 is equal to 1 over x squared. So a negative exponent means that it's the inverse of that same positive exponent. Just, x to the minus 4th would be equal to 1 over x to the 4th. Likewise, 1 over x to the 4th is equal to x to the minus 4th. The negative exponent just means that it's in the denominator, not in the numerator, if it's positive. It's inverted. So negative exponents mean it's inversed. It's inverted. It's 1 divided by. What about fractional exponents? What about x to the 1/2 power? raise it not to 1, but to a half. It's not as big as x to the 1. X to the 1 is x, but this is x to the half, so it's got to be smaller than that. What is it equal to? Well, we can look at it this way. What's x to the 1/2 times x to the 1/2? When we add the exponents, that's equal to x to the 1/2 plus 1/2, which is equal to 1. So x to the 1/2 is the square root of x, because multiplying x to the 1/2 times x to the 1/2 equals x, and that's the definition of the square root of x times the square root of x is equal to x. That's the definition of a square root. So this is actually the square root. So fractional powers are roots of the number. What about x to the 2/3 power? Well, this is actually equal to x, the cube root of x squared, because it's the same as x squared. Well, I don't want to do it that way. Just accept me for this rather than me confusing you further. X to the 2/3, you take the top number and you square, you apply that to the number under the radical, and you take the fractional part and put it in the radical location. So x to the 2/3 is equal to the cube root of x squared. If we multiply x x squared times the cube, if you multiply this 3 times, you'll end up with x squared. That's what the third root of x squared is. So that means that we not only have just plain integer positive exponents, but we have fractional exponents, negative exponents as well, and we'll encounter these, and we need to know what we're talking about. What about x to the 0? What in the heck could that mean? X to the nothing power. Well, x to the nothing power is equal to 1, and that's because x to the any power divided by x to the same power is equal to x to the difference between the powers, which is equal to x to the 0. So if the numerator and the denominator are both the same, then it's x to the 0. Well, when the numerator and the denominator are both the same, that's equal to 1. So x to the 0 power is equal to 1. Are there any questions about exponents? When we multiply exponents, we add them. They have to be the same. You can't do this. X squared times y cubed. You can't go any further than that. You can't add these together, because this one is the cube of y and this one is the square of x. And those two things can't be expressed as either x or y. They have to be kept separate, because x and y can vary independently of one another. So we can't lump them into one thing. They have to be kept separate. Any more questions or any questions?
So far, no. Any questions? Type them in the chat now.
All right. So none of this is really directly on the exam, but it'll come up in math when we're talking about things. So now we want to talk about rectangular coordinates. This is on the test. And you probably have seen graphs with coordinate systems on them, like we'll draw this and this. So here's our coordinate system, and we usually call this the x-axis, although we'll have other names for it, which you'll see, and we call this the y-axis. And this allows us to graph, this is a graph, the relationship between x and y. So for instance, suppose we have the expression y equals x squared. So we say y is a dependent variable and x is the independent variable. So we can vary x and that will determine what y is. So y will be the square of x. So let's see what that might be. We'll write y here and we'll write x squared over here. I mean, this is an equation, so both sides have to, one side has to be equal to the other side. So when y is equal to 0, of course x squared is equal to 0 too. Because oh no, let me correct the way I'm doing this. So if this is the value of x, then here's the value of x squared, which is y. Let me do it this way. So when x is equal to 0, x squared is equal to 0, which means y, which is equal to x squared, is equal to 0. So y equals 0. When x is equal to 1, x squared is equal to 1, so y is equal to 1. When x is equal to 2, y is equal to x squared, which is 4. When y is equal to 3, x is equal to 3, y is equal to x squared, which is 9. 3 times 3. When x is equal to minus 1, well, here's a rule we have to remember. Minus 1 times minus 1 is equal to plus 1. Minus times minus equals plus. Plus times plus equals plus. But plus times minus equals minus. And minus times plus, of course. Whoops. So if they're the same, it's plus. If they're different, it's minus. So minus 1 times minus 1 is equal to 1. And minus 2 times minus 2 is equal to 4. And minus 3 times minus 3 is equal to 9. So if I plotted this on here, if this is like 1, 2, 3, this is minus 1, minus 2, minus 3, then if I plot the values, here's x equals 0, y equals 0. Let me put some numbers up on the y-axis here. We'll call this 2, 4, 6, 8, and 10, someplace up here. So when x is equal to 1, y is equal to 1. So that would be like right here. When x is equal to 2, y is equal to 4. So that would be like right here. When x is equal to 3, y is equal to 9, which would be way up here someplace. So we could draw dotted lines to show the relationship between x and y here. And these points indicate the values. Now, minus 1 is also 1. And minus 2 is also 4. And minus 3 is also 9. Someplace up here. So if I draw this shape, it looks something like this. I can't draw very smoothly here, but you get the idea. This is the plot, this is the graph of y equals x squared. These are the coordinates. The coordinates of this are, at this point right here, are 2, 4. The x value is first, and the y value is second. And we write it like that. 2, 4 means that that is the point where x is equal to 2 and y is equal to 4, which is one of the points on the graph of y equals x squared. Is that anybody have any questions about that? These are also called Cartesian coordinates because they are were used by Descartes. They're called Cartesian also. rectangular coordinates. And this is for 2 dimensions. You could have 3 dimensions. You could have a relationship between x, y, and z, for instance. X equals y squared plus z squared, for instance. You could plot that, but you'd have to have a 3-dimensional plot then with a 3rd axis, which would be the z-axis, which would be perpendicular to these 2. And you can even have 4, 5, 6, or 7 variables. Of course, there's no way to draw that in any reasonable way. We can't picture more than 3 dimensions. We can't even portray them very easily. But mathematically, we can have many, many variables. We don't have to just have 2. We can have multiple variables, and we could represent them on graphs, multiple parameter graphs, multiple value, multiple unknown graphs, or multiple variable graphs. But the one we're mostly interested in is the 2-dimensional one, or rectangular. Why rectangular? Because these are at right angles to one another. This angle right here is a right angle. And a rect means right, and like rectify means to make it right. Rectangle means right angle. These are right angle coordinates. It's, by the way, possible to have coordinates that aren't at right angles, but they really are a pain, and there's just rarely a use for such a thing. But you could have coordinates that were not at right angles to one another, but we're not going to worry about that. These are rectangular coordinates, and this happens to be the plot that shows us what the relationship between y and x is. Y is equal to x squared, and this plots it. Now, there's another way of representing these values too, and that is polar coordinates. And polar coordinates are used to represent the same thing, except they do it in a different way. But they end up, the picture's the same, but the approach is different. The axis arrangement is different. So in a case of a polar coordinates, we have I'll draw rectangular coordinates on here first, but then we have, instead of applying the values the way I just showed you, we do it this way. We'll have 1, 2, 3, and this is going to be hard for me to draw, but I'll try to do it. We have a circle which goes through the 3, and another circle which goes through the 2, and another circle, another circle which goes through the 1. So we have the 1 circle, the 2 circle, and the 3 circle. So if we have a point out here, let's say I put a point right here, then I'll draw a line from the center of the graph to that point. That wasn't very well drawn. And I specify its value on the circle, which is about here, about 2.4. Looks like this would be 2.5 right here. So this is about 2.4, the way I drew it. And it has an angle here. And we often use Greek letters for angles. Theta is a common one. That's the Greek letter theta. It's always good for job security and for mathematics and engineering to use Greek whenever possible. We often use phi, some people call it phi. That these Greek letters are often used to mean angles. Capital Greek letters usually for those angles. Not capital there. Anyway, don't worry about that. Theta and phi are 2 of them. This theta is one we're going to use most often here. So we say this is 2.4 at an angle, and that looks to me about 45 degrees. So we would say 2.4 at an angle of 45 degrees. But we could also break this up into its Cartesian coordinates, its rectangular coordinates as well, and we could specify it by its value. Here's 1, here's 2, here's 3. And here's 1, here's 2, here's 3. We could break it into its x and y values. So it also has some equivalent. This is the polar form, and it also has some equivalent rectangular form. Now, I'm not going to try to calculate that for you, but I'm going to talk about how we do that a little bit later. But it's the same point. It's just two ways of representing it. It can be represented as this is called the magnitude. It's called the magnitude of the number, and it's sometimes written like this in brackets because it's never negative. It's always a positive number. These brackets here mean absolute value, means always positive no matter what. So this is a number that's always positive. It's the distance from the center to the point. And then there's the angle. Of course, the angle goes from 0 to 360. And angles are always measured this way. You measure the angle counterclockwise from the x-axis. So this is the polar coordinate form, which is represented by a magnitude at an angle rather than the x and y components which specify where it is on the graph. It would be very hard to visualize or write all the values for it, but we could express this curve. It would look the same, but we could express it in terms of the magnitude and the angle to any point on here. Like we could express this point up here as the magnitude to there and the angle to there. It would represent that point 939. This would be the point 39 right up here where we plotted that 39, and we could represent that also as an angle and a magnitude. Same point, two different descriptions of it. Now, it turns out we're going to be using both rectangular coordinates and polar coordinates to represent the same thing. Why? Because our mathematics is easier in polar coordinates sometimes, easier in rectangular coordinates other times. So we, in engineering, we will use whichever one allows us to have the easiest math as a result. Now that does mean we need to be able to convert between polar coordinates and rectangular coordinates, and I'm going to teach you how to do that. And I don't know if I'll get to that in the last 10 minutes here of the session, but we'll make some progress. Any questions about rectangular coordinates and polar coordinates? Why are they called polar coordinates? Because this looks like the globe of the Earth looking down from the North Pole. We're seeing all the different latitude lines. Of course, this is not a sphere, it's a plane. But if it were squashed into a sphere squashed into a plane, that's kind of look like the North Pole looking down on it. That's why I call polar coordinates. Not the best name, but it would probably be better to call them angle coordinates, but that's not what they call
them. So I don't want to be a wise guy, but somebody said, when would I be using polar coordinates in amateur radio? So my answer is all the time. But so, and I'll a pun intended, stay tuned. So you're going to see lots of things. One other comment, that the chart with the polar coordinates or graphing things in polar coordinates, you leave that on there because somebody wants to make a screenshot.
Okay.
So the polar coordinate on the lower left there, that is not a Smith chart.
No, it is not.
I know you guys see you've got these little nano VNAs and you see kind of different plots and so forth. The Smith chart is a very, very special kind of coordinate system, and I'm not going to talk about it anymore. This is a much more general purpose way of graphing, and it's just a polar coordinate.
And you, of course, learn about Smith charts. And here's the really bad news. Tom and I love Smith charts.
We love Smith charts, and this is not one. Yes, this could be azimuth. Someone just asked it. The angle could be an azimuth angle if you were doing, for example, an antenna pattern. So there's a lots of things that we use polar coordinates for.
Yeah, yeah. In fact, if we do use polar coordinates generally for, but they're not linear. These are linear numbers. We'll talk about that, nonlinear and linear too. But um, exponential and so forth. But
Yeah,
not.
right. We can put a log scale on all kind. We can have lots of fun with this. So
Okay, now everybody, grip your chairs.
don't
We're,
try to do anything complex in the last 10 minutes.
we're going to do something a little
Oh,
basic. Trigonometry.
and people are going to bail out in droves now.
They should. This is this is they never. This is the trig. Everybody says they never taught me it this way. It's not that hard. Believe me. Stay with me here. Let's talk about angles. But trigonometry is measure of triangles. That's what it means. This gonometry part is measurement. Trigonometry is three angle measurements. It's a triangle based thing, but it's not really how it started, and it's not really the best way to understand it. So, but that's what it's called, trig for short, and it will be about triangles before it's all said and done. But let's talk about just angles. How are they measured? Well, they're measured in what? Degrees. Well, yes, they're measured in radians too, but that's not for tonight. Degrees. They're measured in grads too, whatever the heck they are, but they're on my computer, my calculator. Claim it's surveyors use them or something. I don't know. I don't know about grads. I know about radians and degrees, but we measure in degrees. How many degrees in a circle? All of you should be saying, oh, come on, Roll. There's 360 degrees in a circle. Everybody knows that, and they do. And why is there 360 degrees in a circle? You may not know that. It's totally arbitrary. It has no physical connection to anything real. It's just a number. It could have been 431, but not a good number because that's a prime number, but could have been 431 degrees. Why is it 360? The Babylonians had trouble with fractions. The Babylonians had to build stuff, and they had to have some math to do it, and they had to measure angles, and they didn't like fractions. Their math didn't handle fractions very well at all, maybe not at all. So the Babylonians said, well, I want to divide it up into something where it isn't fractions. And 360 is great because it's divisible by 180, 120, 60, 30, 15, 45, I think, 3, 6, 2, 10, and on and on. 360 is divisible by a lot of numbers without any fractions. That's why it's 360. It could have been anything. It's arbitrary. So how else could we talk about angles besides this sort of made-up thing of having 360 degrees? Let's find something that's fundamental to the angle, not something that's arbitrary. Suppose we said, let's look at this angle here, and let's say that this is on a graph. We'll put it on a graph. So here's our angle. It might be theta. And how can we specify? Well, we could say it looks like maybe about 40 degrees, but that's pretty arbitrary. If you don't have a protractor, there's no way of knowing. So they said, well, suppose this had a length of 1. Suppose this line I drew had a length of 1. We'll just say it has a length of 1. Then this line right here, I'll see out another color, this line right here would represent that angle. There's a unique length for that line right there that would change as this angle changed. And so I could specify the angle by the length of that line. The smaller the angle, the smaller the length of that line. The bigger the angle, the bigger the length of that line. How big could that line get? Well, when this thing rotated all the way around up to here, this is 1 up here, so that's the biggest it could get. It could rotate down here to 1. That's the smallest it could get. So this line here would go from 0 when the angle is 0 all the way up to 1 when the angle is 90 degrees. And then as the angle got bigger than 90 degrees, well, then it would start to fall again. We'd have to deal with that to know whether we're talking about an angle greater than 90 degrees or not. But this line here would represent that angle. And by the way, this line here could also be used to represent the angle if we wanted to. Let me pick something out here that's more visible. This line here could have been used. That would have become when the angle's equal to 0, that value would be equal to 1. This would be all the way down. This would come all the way down to here to 1. And when it was up all the way up here, when it was 90 degrees, this value would keep shrinking until it got to absolutely 0, and then it would start to grow again on this side. And they decided to call this line here the sine, abbreviated SIN, and they called this blue side here the cosine, abbreviated COS. So they could have used these two lines. Now the problem is, what if this line isn't equal to 1? If this line were equal to be 2, well then this line here would be twice as big too. I mean the whole if this were 2, this whole triangle would be bigger. And this would be twice as big as that. So that would be confusing. So for different length lines at this angle, you can see how this would apply to polar coordinates, couldn't you? Here's an angle and a magnitude and a value. So what we need to be consistent, so we can talk about what angle we're talking about. We can't just use this side. We have to shrink it back down to 1 by dividing it by this length. Because if we divide this length by itself, then we get 1, and we shrink the whole thing back down to where it ought to be. So we divide this by the length also. In this case, 2, we divide this by 2, and that equals this length here. So the sine is equal to, the real sine is equal to this side of the, we'll call this angle theta down here, and we'll call this side the opposite side, and we'll call this side the adjacent side, and we'll call this side the hypotenuse of the triangle. This is a right triangle. I should probably use a different color because you can't read that. I'll just say hypotenuse. Short. So remember, we have if we have a right triangle, it has to have a right angle. It's got 2 sides and the hypotenuse. So this is like side, usually they say side A, B, and C, where C is the hypotenuse. And if you remember, there's a thing called the Pythagorean equation. This is an equation. It says A squared plus B squared equals C squared. And we sometimes say that the hypotenuse is equal to the square root of the sum of the squares of the other 2 sides. Right? I can take the square root of this equation, take the square root of C, and I get C squared, I get C. Take the square root of A squared plus B squared, and I have to take the square root of the whole side. So the hypotenuse is equal to the square root of the sum of the squares of the other 2 sides. Remember, my favorite, all my philosophy comes from The Wizard of Oz. The wizard at the very end, when the Scarecrow doesn't know anything. He says, I need a brain. He gives him he gives him a diploma, which therefore means he's smart by definition. And all of a sudden he says, the square root of the hypotenuse is equal to the square root of the sum of the squares, the square root of the sum of the other two sides, or something like that. He says it wrong, by the way. It's equal to the square root of the sum of the squares of the other two sides. Okay, so this is the hypotenuse side. This is the opposite side from the angle, and this is the adjacent side. And in order to get the hypotenuse back to 1, we have to divide everything by the hypotenuse. And then we get this original triangle, which has the real sine and the cosine. So we say that the sine is equal to the opposite angle, the opposite side, divided by the hypotenuse. That the cosine is equal to the adjacent side divided by the hypotenuse. And there's one other line that we could draw. And that is, if we could, I didn't leave myself a lot of room here. If this were a circle, if this were a circle here, where this is with a radius of 1, then there's another line we could draw, which is this line here, which is the tangent to that circle at that point where the point is. And this line here, I guess I'll need to use another color. This line here, that is equal to what's called the tangent of theta. So this is the sine of theta equals the opposite over the hypotenuse. The cosine of theta is equal to the let me draw this neater. Again, neatness is important. Cosine of theta is equal to the adjacent of the hypotenuse. And it turns out, for reasons I haven't got time to prove to you, that this line here by similar triangles is equal to the opposite, the tangent, written tan, is equal to the opposite over the adjacent. It's equal to this divided by this, or this divided by this. That will be the same. No matter how big the triangle is, it's this divided by that. And if you're mathematically inclined, you can figure out how these similar triangles work out that way. I don't want to take the time to do it. So there's a memorization tool for memorizing this, and that is so ka toa. As if this is an Indian chief, so ka toa. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Sine, cosine, tangent. The sine, the cosine, and the tangent of this angle. And what's kind of neat is if these are the x and y coordinates, then the x and y coordinates are actually sines and cosines of the angle. Because this is the y coordinate, that's the sine of the angle. This is the z coordinate, the x coordinate, this is the cosine of the angle. So we can get, of course, to get that back, we have to know what the hypotenuse is, because we have to multiply the answer by the real hypotenuse to get the real value of this. Okay, I'll pick this up next week. That's as far as I want to go. Are there any questions about sines, cosines, and tangents and their definition?
Nope.
So remember that it's just a way of measuring angles. And we have to get all of the angles, all of the triangles back to the same size with a hypotenuse of 1. So we divide all the values by the value of the hypotenuse, and that will equal a triangle with a hypotenuse of 1. Okay.
All right. I have your video clip.
Okay, do it. I'll stop.
Excuse me. Um,
And again, if you don't understand any of this, you're still going to pass the test and
still
probably get
gonna
all these questions right.
still get the answers right. All right. Here we are. You see the wizard?
Not yet. There he is.
All right. Let's see what he has to say.
Where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
PhD?
That's Doctor of Thinkology.
Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy! Rapture! I've got a brain! How can I ever thank you enough?
Well, you can't.
That was not correct. It's not just some of the square roots.
It's so many things, and he's talking isosceles instead of a right triangle, and it's some of the square roots, and I think he's got the hypotenuse mixed up. So it's just awful. But who knows? Great movie. I'll have to offline. I'll tell you about that movie. All right. So we're going to do a little review of chapter 3.
Pay no attention to that man behind the curtain.
Yeah, exactly. Well, the best part, I don't think we're in Kansas anymore.
It's amazing how many things from that movie are in our everyday.
Right. Okay, I'm going to share.
Lions and tigers and bears. Oh my.
Seeing exam questions.
Yes, I am.
All right, we'll do all of chapter 3, and I'll do them section by section to kind of keep things in order. As I've always said, if you feel the need to disconnect right now and you want to come back and watch this part tomorrow, that's fine, because I know it's getting kind of late. Oops. I didn't mean to offend anybody in Kansas. I forgot we have a national audience here. So my nephew went to University of Kansas. I'm really familiar with Kansas.
Although we don't like the Chiefs very much here in Baltimore.
We don't like the Chiefs, but
or the Royals for that matter.
yeah, they beat us up bad a couple of years ago. Let's see. So let's get on with the review. So going all the way back to rules stuff, and this has to do with where you are in the band. So just take a look here. I want to show you. You can download this chart from the ARRL. Okay, and I would take and print one of these out and maybe make some marks on it and hang it up someplace where you see. Where you'll see it all the time, and it'll just help you remember the question. So this question says, why is it not legal to transmit a 3 kilohertz bandwidth USB upper sideband signal with a carrier frequency of 14.348? Okay, so you could kind of draw that on here right in the 20-meter band, and 14.348 will be, see where my mouse is, where my little arrow
You can see that, yeah.
is right up here at the top of the band, and since it's 348, you can see that it's just 2 kilohertz below the top of the band, yet the question says you have a 3 kilohertz bandwidth signal. So that means that the upper kilohertz of the signal is outside of the band. So as a memory jogger, you could kind of just draw that picture and write 14.348 and put a little black line with a Sharpie, and then it would be +1 outside of the band. So and there's several questions like this. So when using a transceiver that displays the carrier frequency of phone signals, which of the following displayed frequencies, meaning of these answers here, represents the lowest frequency at which a properly adjusted lower sideband emission will be totally within the band. So it needs to be, remember, lower sideband, so you want to be 3 kilohertz above the lower band edge. So does it give a band? No, but we'll just take a look at the 40 meter band. And here normally, and you know, the general doesn't have all the phone privileges in the band, but the advanced and the extra have more. So the middle here is 7.125. Okay, so you have to be at 7.128, 3 kilohertz up from that point there to make sure that you don't get into this part of the band where phone is not permitted.
Now, the interesting thing is that foreign stations are permitted below 7125. So you
Right.
have to be very careful that you just don't go charging down there and you hear some foreign.
Everybody who's been in a contest has sooner or later called some station down here outside of our phone privileges. And the reason they're down there is because they don't want to. When you do that in Antigua, you just don't want to work U.S. stations, right?
Yeah, I mean we getting so much QRM we can't hear anybody.
Yeah.
So
So you go down here and you can work the Europeans or whoever. And
yeah, it's always a difficult decision to make because we can't work the U.S. But sometimes we can't find a clear frequency anywhere else, and at certain times of the day when Europe's coming through, we just go down there.
so anyway, you got to stay 3 kilohertz above the lower band edge. And again, as I showed here, it's the edge of the phone band, not the edge of the whole 40 meter band in this particular example. Okay, so here they ask you to kind of do a calculation on what's the highest legal carrier frequency on the 20 meter band for transmitting a 2.8 kilohertz wide upper sideband data signal. Okay, so again, on the 20 meter band, the top is 14,350, so you have to be 2.8 kilohertz below that number, and it's a subtraction. It's
This is the
trick question. Pardon me. It's a data signal. I almost fell into the trap. All right. So the boundary for data is 14,150 right here in the middle. Okay. So you have to be 2.8 kilohertz below 14,150. All right. So which is about this. Okay. Yep, I forgot about that, and I answered this for somebody in an email the other day, and I looked at it earlier today, and I still almost made the same mistake. So watch out for this one. It says data, and again, the boundary for data is right there at 14.150. And again, I think it will help you remember that if you just draw it on here and pin it up on the refrigerator or wherever you spend most of your time. In my house, it would be in front of the refrigerator. And it'll just help jog your memory. So, because somebody said, by the way, can you take this drawing into the test? No, you just have to know this stuff.
There've been a lot of people ask about that. Maybe someday we'll do it, but this is extra class. You're supposed to be able to remember some stuff.
I mean, and everybody prints this out and puts it in their shack someplace so that they can, like, what are the authorized frequencies for this or that? Okay, so may an extra class operator answer the CQ of a station on 3.601 megahertz lower sideband? Well, let's just take a look at that. 80 meters, 3.601 is right here at the like 1 kilohertz above the bottom of the phone portion of the band, which means, what did they say, at a 3? Well, it just says lower sideband phone. So the answer is no, because some of your sideband will go down below the edge of the band. 3.601, typically you have a 3 kilohertz bandwidth, so you'd be encroaching 2 kilohertz into this part of the non-phone part of the band.
Now, there are a lot of questions on this, and the reason is because this is a problem that many people don't seem to understand, and they violate the rules. So we're trying to make sure people understand how to read their radio frequencies.
I will, and I'm gonna say this, and it would be better if I drew a picture, but there was on the 20-meter band. It's generally accepted that 14.230 is kind of the single sideband. I'm sorry, the slow scan TV frequency. So there was a guy operating, he was in a park or something, and he was on 14.228, and he was kind of complaining that he was hearing this funny noise and a warbling and so forth. And the reason is that he was tuned to sort of overlap about a kilohertz with that slow scan TV signal, and that's what he was hearing. And he didn't understand why that was happening. It was he kept asking. People were telling him, he said, "Well, if you move a little bit, you can move away from it." And it was clear the way he was talking that he didn't understand that his receiver had a 3 kilohertz passband, and that the way he was tuned, he was only 2 kilohertz below that other signal, and that's why it was interfering with him, and vice versa. So I 100% subscribe to putting a lot of questions like this on here because it's a problem. People just don't understand that the signal isn't where the carrier frequency is indicated on your radio, it's above or below it as well.
Another thing we've had trouble with, this is probably worth taking a second on. When I used to operate a phone from W3LPL over in the contest, DX contest, I would try to operate at 14.153, which is, 14.150 point a little bit.
A little bit, as little as possible.
Get as low in the band as I could because there wouldn't be any phone stations from the U.S. below me to interfere with me. It could be foreign stations. Well, then people would tune below me and say, well, I can still hear you. Well, of course you can. You've got a receiver with 3 kilohertz bandwidth, and you're 1 kilohertz below the edge of the band. You're going to still hear me. I'm not going to sound right because I'm too high, but you'll still hear me, and you'll still hear me until you're 3 kilohertz below the band edge. That doesn't mean I'm below there. That means your receiver is hearing me below there. For the same reason that Tom just said, your receiver has a bandwidth, and when you're listening on upper sideband on 14.149, you're also hearing 14.150 and 151 and 152. So you are going to hear wider than just the number on your
display. All right, we'll quit beating that drum. Control operator stuff, I guess. Who must be in physical control of the station apparatus of an amateur station aboard any vessel or craft that is documented or registered in the U.S.? Okay, so right off the bat, the person should have a U.S. license. Or it could be somebody who's authorized to operate in the U.S. So it's this answer. It has to be an FCC issued amateur license, which is all of us, or somebody who's from another country, he's from Canada or whatever, and has been authorized for operation in the U.S. You just consider this ship or airplane is part of the USA. And I think it's pretty clear that I don't think there's any other possible. It says any person holding an FCC amateur radio license. Once you see that should tell you got the right answer.
By the way, the same thing applies on ships of other countries.
You have to be authorized for that country.
So if you're traveling on a Norwegian air cruise ship that is registered in Norway, you better have a reciprocal operating permit for Norway, which would be a SEPT.
How about Greenland?
Iceland or whatever. Whatever it is. Okay. Used to be Greenland was KG-1. It was the U.S. troops up there after the war
Operate, yeah.
had KG-1 as their call sign.
All right, so somebody asked me, does the 3 kilohertz rule apply to VHF and UHF? Well, it depends. I know that's the standard answer. It depends on the bandwidth of the signal you're transmitting. So, for example, if you're operating a 2-meter FM, your bandwidth is going to be more than 3 kilohertz. The channel spacing is like 15 kilohertz, right? I think
Yeah.
a typical FM signal on 2 meters, I think the bandwidth is around 8 kilohertz. Is that 16, 8 on each side?
Yeah.
So, so you have to be if you were on FM phone and you would have to be at least 8 kilohertz away from the edge. So think about what kind of signal you're transmitting. This 3 kilohertz thing is only for single sideband or usually data too.
Yeah. And you have to look at those charts that there are phone allocations and CW allocations on some of the VHF bands, 6 meters and
Yeah, you could have single sideband on those bands too, and then 3 kilohertz would be right.
And there's a CW part you can't go into with a phone signal, so you'd have to be on phone above that edge.
Right.
Nobody uses phone down there near that edge anyway.
Nobody does that anyway. So you see here on 2 meters from 144.0 to 144.1, no phone or data or anything is allowed down there. It's CW only. And people using FM are up in the top part of the band anyway.
The biggest problem is NHF, but you could have a problem on 6 meters if you.
Somebody's asking, is there a limitation for AM phone bandwidth? I don't think so.
Yes, there's a limitation. I mean, I think it's 6 kilohertz.
By rule?
Yes, I think so.
All right, here's the 60-meter operation. So what's the required transmit frequency of a CW signal for channelized 60-meter operation? And of course, again, this is as of today with today's rules. And again, remember this chart. You see here right over on the left, it says CW and digital, and it tells you exactly what frequency you're permitted, which of course is at the center of the channel. So it's that answer. What's the maximum power permitted on the 2200 meter band? And that's on the chart. It says 1 watt EIRP. What's that? Equivalent isotropic radiated power. So 1 watt equivalent isotropic radiated power. Totally unrelated to anything with spectrum or bandwidth or so forth. If a station in a message forwarding system inadvertently forwards a message that's in violation of FCC rules, who's primarily accountable for the rules violation? And it's the originating station, the control operator of the originating station. Except in some parts of Alaska. What's the maximum power permitted on the 630 meter band? Okay, let's take a little peek. 630, 5 watts maximum, except all this stuff in Alaska within how many miles? 496. I'd love to know what treaty that was, but it's 5 watts EIRP. This is a wording that was funny, Roll. It says, if an amateur station is installed aboard a ship or aircraft, which installed could mean you've got a 2-meter HT in your hand, what condition must be met before the station is operated? So the operation must be approved by the master of the ship or the pilot in command of the aircraft. What licensing is required when operating an amateur station aboard a U.S. registered vessel in international waters? And again, any FCC issued amateur license. So basically, the U.S. vessel in international waters is like it was part of the USA. There's no requirement for, there's no such thing as these endorsements. Radio telephone operator permit does not allow you to operate in the amateur bands, and it doesn't have a restriction by license class. Which amateur stations may be operated under RACES rules? So the key here is that you have to be certified. Okay, so any FCC licensed amateur station certified by the responsible civil defense organization. Okay, we do, we can't get into all of I don't want to call it complications, but RACES and ARES are very well organized. They have great training and they have great organization for how you respond and what you do. So to participate in that, you've got to take the training and be certified. You can't just show up with a radio and get involved.
I have an answer about the power. No, here's why I'm confused about it.
Which one?
No amateur station transmission shall occupy more bandwidth than necessary for the information rate and emission type being transmitted in accordance with good amateur practice. Very vague.
Okay.
There's no number except for 60 meters. It's 2.8. But on other bands, it's good amateur practice. And what is needed for the necessary information rate and emission type being sent. So they're saying if it's excessively broad, and by the way, who gets to determine what's good amateur practice?
The FCC. Duh. Okay, moving right along. It's getting late. What frequencies are authorized to an amateur station operating under RACES rules? And it's all frequencies authorized to the control operator. Maximum bandwidth for data emission on 60 meters, and we've said this like 100 times, 2.8. And this is about filing with the Utilities Technology Council. How long must an operator wait after filing a notification with the UTC before operating? And it's 30 days. If you don't hear from them after 30 days, you're good to go. And I think that's the only answer that has 30 days. What notification? This is basically the same question. What notification must be given before transmitting on 630 or 2200? You have to inform the UTC. What portion of the 630 meter band are phone emissions permitted? And that's the entire band.
Such as it is.
Such as it is, if you can figure out how to do that. All right, 3.2. Which of the following constitutes a spurious emission? So that's emission outside the signals. All these things look like reasonable answers, especially C. But unintentional interference is not a spurious emission. So it's this emission outside the necessary bandwidth that can be reduced or eliminated without affecting the information transmitted. What distance must an amateur station, within what distance must an amateur station protect an FCC monitoring facility? That's 1 mile. There's a table in the book that has all the locations, but there's some question as to whether it's still valid. But you just need to know the 1 mile and then look in the table in the book and see if you're nearby one. What happens if you're near an airport? Which of the following additional rules apply if you're erecting an amateur station antenna structure at a site at or near a public use airport? So you may have to enter.
No.
Oh, wrong one. I'm sorry. You may have to notify the FAA and register with the FCC. I thought may have would be a clue, but it's not. So you don't have to enter all this height and so forth. You have to notify the FAA and the FCC. We're working on this issue now because we're moving over to a site by the Martin State Airport over in Middle River. But we think we don't have to do anything special.
Is that a public use airport?
Yeah. PRB1, be careful. People tend to think it applies to homeowners associations, but it does not. It's state and local zoning.
We'd like it to, but it doesn't.
Yeah, wishful thinking.
They've been trying. ARL's been working to try to get that to be the case.
This, what limitations may FCC place on an amateur station if its signal causes interference to domestic broadcast reception, assuming that the receivers involved are of good engineering design? And by the receivers, they mean the consumer receiver, the TV set or radio or whatever it is that your neighbor's watching or listening to. It's not your receivers. So if your transmitter is interfering with a receiver and the receiver is not defective, it's well engineered, then they can give you quiet hours. And that's this: the amateur station must avoid transmitting during certain hours on the frequencies that cause the interference. So what does PRB1 require? Reasonable accommodation. And this one, you got to remember this. The answer is minus 43.
I didn't cover this, but
All right, well, the maximum mean power level for a spurious emission below 30 megahertz with respect to the fundamental emission. So any spurious emissions have to be 43 dB down from the fundamental signal.
remember the 20 dB is 100, 30 dB is 1,000, 40 dB is 10,000, and
3
40
dB
dB
is 2 times 10,000.
20,000.
20,000
1/20,000th of the carrier frequency.
carrier.
Power. Pretty low. But still copyable if you're running.
All right. Station control. Not too many here. Under what situation may a station transmit third-party communications while being automatically controlled? There's some confusion about this. People are asking me questions. The key here is while under automatic control. So if you're not under automatic control, you can use phone or CW, for example. So automatically controlled, it's only RTTY or data. This is about automatic control. What's the maximum permissible duration of a remotely controlled station? I'm sorry, it's not automatic, it's remotely controlled. If the control link malfunctions. So it's got to shut down within 3 minutes. Telemetry. Telemetry is measurements. You look at the metry measurements. Measuring is called metrology. So it's not these other three, it's measurements.
And tele means different. Telephone is a distance voice. Telescope is distance seeing.
Telemetry is distance measurements. This D looks like it might be right, but it's not. Which of the following is required in the identification transmissions from a balloon-borne telemetry station? Call sign. What must be posted at the location of a station being operated by telecommand on or within 50 kilometers of the Earth's surface? It has to be all these things. Maximum permitted transmitter output power when operating a model craft by telecommand. That's, you're limited to 1 watt. Which of the following amateur stations may transmit one-way communications? And it could be, let's see, it could be A, right? Space station, beacon station, or telecommand fits the requirement. Not repeaters, message forwarding. Amateur satellite service. Which of the following may transmit encrypted messages? Telecommand signals from a space telecommand station. A space telecommand station is not communicating, as transmits communications.
That's it.
I'm just checking to make sure. I got to read all of them sometimes.
That's the initiate, modify, or terminate. That's the
It commands the functions. Okay. Which of the following HF amateur bands include allocations for space stations? So it's this one. I guess one of the things you can, I guess the easiest thing is just remember that it's the 40, 20, 15, and 10. Not all, not only. Which VHF amateur bands have frequencies authorized for space station? And that's 2 meters only. And the UHF bands have frequencies authorized for space stations. It's 70 and 13. There was a question about 23 is also authorized, but it's not on the list, so just don't worry about it.
Yeah, that's true. We had that issue.
It's come up before.
Which of these following are really?
So it's not 70 only because it includes 13, but it's not 33. So the B is the correct answer within the context of the question. It's not, and I've told you this before. Some of the questions aren't necessarily quote unquote complete. Which amateur stations are eligible to be telecommand stations of space stations subject to the privileges of the class of operator license? So, for example, a technician can only operate in the bands authorized. So, it's anybody who's designated by the space station licensee. Which amateur stations are eligible to operate as Earth stations? And this is the trick question. Somebody emailed me about this. You have to be general, advanced, or amateur. Oh, I'm sorry. I'm thinking of another question. Any amateur station subject to the privilege of the class of operator. So it's not restricted to certain classes of license. That's another question. Hope I didn't confuse you too much. Wait a minute, I gotta erase this. Where am I at? 3.5?
Yeah, I just finished satellites.
This is about VEs and VECs. So
remember, I just want to clarify one thing. An Earth station, my station is not an Earth station, even though I'm on the ground below 50 kilometers. An Earth station is a station communicating with a satellite. So it's the ground side of the space communications. So just beware of that.
Not
It's
just any station that happens to be on Earth.
right.
Got it. Okay, so what types of out-of-pocket expenses do the Part 97 rules state that VEs and VECs may be reimbursed? And it's this one: preparing, processing, administering, and coordinating an exam for an amateur radio operator license. Who is tasked by Part 97 with maintaining the pools of questions for U.S. amateur license examinations? So this is the VECs. And there's always confusion about this. So the VEs are the people who give the tests. The VECs are the coordinators who, among other things, maintain the question pools, organize, certify VEs, and so forth. So VEC is an organizational entity. VEs are people. So this organization of VECs is responsible for the question pools. What is a volunteer examiner coordinator? All right.
Yeah.
So again, it's a person. So that eliminates two of these questions right away. No, I'm sorry. The volunteer, I got it backwards. The volunteer examiner coordinator is an organization, and it's not paid. It's entered into an agreement with the FCC to coordinate, prepare, and administer. Okay. So the VEC, the coordinator, is an organization. The VE is a person. I'm trying to go too fast. Whoop, and I just skipped one. Okay, so you got a VE team, people given a test. What do they do with the application form if the examinee does not pass the exam? So in this case, they don't keep any records, they don't destroy anything, they give the application document back to the examinee. So fundamentally, officially, there's no record that somebody didn't pass.
I think actually that I could be wrong about it. Maybe somebody out there's a VE. I think they do send a statement on the exam session about how many people passed and failed.
Yeah, they keep track.
I don't know if that goes to the FCC or not.
I don't think so. I think they only upload to people who passed. They keep records, and I'm sure somewhere at that level there's a record of the name of the person who took the test, but it's an unofficial local thing. It doesn't go to the FCC. Okay, who's responsible for the proper conduct and necessary supervision during an amateur radio operator license examination session? Okay, so the people who are there are the VEs. So each of the VEs who is administering the exam is responsible for these things. Somebody asked me if it says when you're going through the review, if you do not click clear, does it remember what you got on each question? I can't remember. I'll have to check that for you. It seems to me somebody told me that once you log out, it clears it. So when you go back, it doesn't remember. I'll have to check that offline. All right, what should a VE do if a candidate fails to comply with the examiner's instructions during an amateur operator license exam? So you're done. If you fail to follow the instructions, they terminate your exam. Nobody else can keep taking the test. They don't terminate everybody. They don't give you a warning. They probably will, but they don't have to. To which of the following examinees may a VE not administer an exam? So it's relative. So again, think about me and my son and daughter. I just kind of recused myself when they took their exams. And now here's what happens if you fraudulently administer. So you basically mess with somebody's score and pass them or give them a hint or something like that. So any kind of fraudulent administration can mean revocation of your license and your operator, your station license and operator license.
Again, they're pretending they're two different things. But
Yeah, we'll pretend they're two different things. Think they'll ever fix that?
I don't know.
Too complicated.
Too many places where it already says that.
Yeah, it's too many things to change. What must the administering VEs do after the administration of a successful exam for an amateur operator license? Okay. So they don't send it to the FCC and they don't send it to the VEC for grading. They submit to the coordinating VEC according to the coordinating VEC instructions. That's a lot of strange words, but the point is they don't send it to the FCC, so that eliminates two of these questions. And of course, they don't give it back to the applicant. And the grading is not done by the VEC; it's done by the VEs right there on site. So try to wrap your head around that this is the right answer.
If you took an exam anytime, you remember they were grading them right there.
Yeah, they grade them right there. What must the VE team do if an examinee scores a passing grade on all exam elements needed for an upgrade or new license? Again, it doesn't go to the FCC. And by the way, they don't issue the license. So 3 VEs certify that the examinee is qualified for the license grant and that they have complied with administering the VE requirements.
Big thing is 3.
It's 3, so key on 3.
You can't give an exam without at least 3 VEs.
3 VEs have to monitor it, and like when I was on the VE team in person, 3 VEs independently grade the exam.
Yeah, there's like at least a half a dozen VEs.
Yeah, we usually had to have 6 or 8 people.
Because all the stuff that has to get done, but 3 of them would sign off on everything.
Okay, miscellaneous rules. By the way, I'm only going to do these. I'm not going to jump into chapter 4 for the review. We'll do that next week. So this is the old doctor, it hurts. What must the control operator of a repeater operating the 70 centimeter band do if a radiolocation system experiences interference from that repeater? So you have to stop doing that. Cease operation or make changes that mitigate the interference.
I missed that question too. I somehow skipped over it.
The National Radio Quiet Zone is at the National Radio Astronomy Observatory. The clue is here, it's not any of the places named. It's in West Virginia, but they don't put that on here. So it's if it's the name of a place, it's not the right answer. It's the National Radio Astronomy Observatory. Okay, this has to do with, I think, well, I won't say. Which of the following apply to communications transmitted to amateur stations in foreign countries? It's got to be C. There's no requirement. You can get on the air and hear people talking all kinds of languages, and it's not exclusive use of government or non-government organizations. It should be either incidental to the purpose of amateur service or remarks of a personal nature. What is an IARP? Okay, so here's how I remember this. The IARP, A is Americas, so it's this answer.
Although it does really stand for
It's not even, it doesn't even stand for Americas, but
That's how you remember it.
that's how you know which answer is right. The IARP is for the Americas. And then here's this bizarre thing about the public notice. So if you're operating in accordance with CEPT or CEPT in foreign countries where permitted, you have to have this public notice DA 16-1048 with you.
You can have it tattooed on your arm, maybe.
I think I'll just carry the paper. Okay, now European CEPT. See that E? Remember, A was for Americas, E is for Europe. So, which of the following operating allows an FCC licensed U.S. citizen to operate in many European countries and European countries to operate in the U.S.? CEPT. So, just the E is for CEPT and the A is for Americas. Not really, but that helps you get the answer.
I think the E actually is for Europe.
Is E for Europe? Okay. Okay, here's the Hedy Lamarr question, 222. What privileges are authorized in the U.S. to persons holding an amateur service license granted by the government of Canada? So it's got to be the overlap of Canadian and amateur extra in the U.S. So they can operate with their Canadian privileges, but only as long as it's within the U.S. extra privileges. Okay, under what circumstances may a dealer sell an external RF power amplifier capable of operation below 144 if it's not granted FC certification? So it has to have come from an amateur radio operator. So if a ham built it, used it, and it's used at an amateur station, then the dealer can resell it. Did you make some comment about asking for their license when somebody asked me about that?
I didn't exactly word this right. I said it had to be used equipment. It had to be constructed or modified by an amateur radio operator. So that's a little different from what I said.
All right. Well, it has to have been built by a ham for use at a ham station.
Yeah, I said it just had to be used. It has to be, well, it has to be built by a radio ham.
The ham has to have built it for use at a ham station.
Yeah, I think I actually didn't state that correctly.
By the way, you should send me a copy of your outline so I can keep track of what you're doing.
Yeah, I should. I don't know why I can do
Okay, so the A line is parallel to and south of the border between the U.S. and Canada. You know, flip to that picture in the book and look at it for a while. Amateur stations may not transmit in which of the following frequency segments if they're located in the contiguous 48 and north of line A. So it's this one, the 420 to 430. Not the other answer is not correct. 440 to 450. It's 420 to 430. Under what circumstances might the FCC issue a special temporary authority to an amateur station to provide for experimental amateur communications? When may an amateur station send a message to a business? When there's no pecuniary interest. So there's no dollar limit, but it is allowed if nobody gets paid for it.
So here's something interesting. You can't go back, but E1FO3.
Okay.
Under what circumstances may a dealer sell an external RF amplifier capable of operation below 144 megahertz if it has not been granted FCC certification? The answer is it was purchased in used condition from an amateur operator and sold to another amateur operator for use at that operator's station. that answer that's in that question is not right. That question is not accurate. E1F03.
Okay. So you're looking at it in the back?
I'm looking at the back of the book, and I haven't gone online to see, but
Yeah. All right, we'll have to let them know.
yeah.
Let me see. When I get done with this, we'll check it in the other.
At CVEC site.
Yeah. All right. So let's just do these last few real quick. Which of the following are prohibited? This one: communications transmitted for hire or material compensation, except as otherwise provided in the rules. So you can talk about religion. You can speak in other than English. Who may be the control operator? This is the one that I was alluding to earlier. Who may be the control operator of an auxiliary station? So it has to be a technician, general, advanced, or amateur extra operator. So people have asked, well, why is that not the same as A? And the answer is there still exist novice licenses, and novices are not permitted to be the control operator of an auxiliary station. So they don't issue novice licenses anymore, but if you have one, I guess you can renew it. Same is true of advanced. So that's why only technician, general, advanced, amateur, extra is the right answer here, because this other answer would include novices. Which of the following best describes one of the standards that must be met by an external RF power amplifier if it's to qualify for a grant of FCC certification? The answer is this one. All right, so if I go to sub-element, what was it?
Okay, I've resolved the question. Apparently, we revised that question, and the question is in the exam that you or practice exam is correct. The one in the back of my book is wrong.
Ah,
So I don't know whether that's been fixed in the current books, but there may be an errata out there for the manual to replace E1F03D.
so my book has the answer you just read a couple minutes ago. Purchased and used condition from an amateur operator and sold to another amateur operator.
That's wrong.
So the question that you will see on the test is this. Is that right?
I got it. Yes, that's correct.
Okay. All right, we'll send out a little blurb about that because I'm sure it's kind of.
We should probably go online and see if there's a errata to fix it, but
Yeah, we'll do that later. All right. Thanks to everybody who hung in there. We had 380 some logins at the beginning. We're down to less than half of that, which is totally expected.
yeah, it's been 4 hours. My gosh.
I get it. Let me make sure I save the chat. I like to go.
By anybody while we're still here before we pull the plug real quickly?
Any other quick questions? Welcome to send us an email. Yep, I gotta go.
All right. See ya.
Talk to you soon. See everybody next week.
Cheers.